Good morning, everyone. My name is Puneet Kansal. I am mentor at GeeksforGeeks. In this session, we will discuss about CPU scheduling, which is one of the most important topics in operating system. Which is one of the most important topic in operating system. Every year, almost every year, you will find out a question from CPU scheduling. You will find out a question from CPU scheduling every year, almost every year. And these, I will say, these are free marks. These are free marks because this topic is so easy. You cannot even make any mistake anywhere. Okay, straightforward questions come in this from this topic. Straightforward question. 2 marks are compulsory. That should be compulsory yours only. Okay, sometimes 4 marks paper come also come, means 2 marks, two questions come, related questions come in the exam. So 4 marks may also get from this topic. Okay, very easy topic. Just you need to understand how the things are going on, and the question will be straightforward. Okay, the only thing is that you will not cram anything. You need to know, okay, how that thing is working. That's it. Okay. Okay, so I welcome you all. Very good evening, Gate aspirant. Nice to see you back. Nice to see you back, Digit. So one thing is ensure before starting this session, let me ensure the new people here who are joining the session first time. We are covering, let me tell you, we are covering the five most important topics, from every subject in this series of Gate Crash course. We are covering five most important topics from every subject. This is actually first topic I'm covering from operating system, one of the most important topic from operating system, and I will cover other four other sessions every week. One session will come, okay, from for operating system. So you can check out the complete schedule for this crash course in the description, and the course, this complete crash course is free of cost. And how this can benefit you, so I always speak the same thing. This is going to help two type of students. One is who are completely, who are saying that, sir, we cannot crack the gate, we are not sure whether we will be able to crack the gate exam. So if we are taking this free crash course, complete free crash course, if you are taking all the lectures, then this is my surety that, okay, you will definitely at least clear the gate exam, because you are covering the most expected topics in its entirety. You are finishing this topic. Okay, five most important topics you are finishing from every subject. So there is a very high probability that you are going to attempt these questions, and you are going to at least clear the gate exam. Okay, so, and second type of student who will get benefit is that who already preparing from the complete year or maybe 2 years. They can revise the five most important topics in this gate crash course. Okay. Okay, so let's move to our today's session. Now let's move to CPU scheduling. What is CPU scheduling? So in CPU scheduling, actually we will schedule the CPU. We will schedule the CPU actually among the different processes. Okay, actually this is the job of operating system. Operating system is simply scheduling the CPU. CPU is a resource. CPU is a resource. Okay, there are many processes maybe running in the system. Maybe you are playing games, you are also listening music, you are also watching the lectures, you are also completing your project, some coding project at the back end. So you may have opened many applications, many programs, or I say many processes you are running at the same time in the system. Okay, so these processes actually need to be scheduled on the CPU. These processes need to be executed. So who is executing these processes? Processes are nothing, just processes are the programs while execution. So these processes, games need to be executed, music program need to be executed. So these need CPU for execution. So who will get the CPU? This will decide by the operating system. Operating system have various techniques to schedule the CPU among the processes which are running inside the system. So which process will get the next will get the CPU. This is decided by the operating system, and this is what we are going to discuss now, how operating system is scheduling the CPU among the processes. Okay, this is what we are going to cover in this session. So I leave this because I think I do not change the index. Otherwise, we will cover the basics of the CPU scheduling. Then in this session, actually, we will cover various CPU scheduling algorithms. From every algorithm, I will take one question from my side, one example from my side, and one question from gate. I will take one question from gate, one question from my side. From every algorithm, we have lots of CPU scheduling algorithms with us. Okay, so we will study all the CPU scheduling algorithm, and I will take one example. Next question will be from gate that you people need to solve. Okay, that you people need to. Okay, and we will cover all the scheduling algorithm. Okay, so this is the basic definition of the CPU scheduling. You already know CPU scheduling is a process of determining which process will on the CPU, which process will on the CPU. Okay, we are operating system is actually determining which process will on the CPU for execution, while other processes will go on the hold. Okay, so we have many processes in our system. Which process will get the CPU? So this thing is known as CPU scheduling. ओके, ये ऐसा ही है जैसे कि काफी सारे बच्चे हैं क्लास में और एक टीचर है, और एक टीचर एक ही बच्चे की एक टाइम पे क्वेरी ले सकता है, तो एक ही बच्चे की एक टाइम पे वो क्वेरी ले पाएगा. तो बच्चे हैं जो दे आर जस्ट लाइक प्रोसेसेस एंड टीचर इज जस्ट लाइक सीपीयू. तो एक टाइम पे एक बच्चा ही अपनी डाउट्स को रिजोल्व कर रहा है, एक टाइम पे एक बच्चा. अब कौन सा बच्चा रिजोल्व करेगा, ये कौन डिसाइड कर रहा है? ये सीपीयू शेड्यूलिंग प्रोसेस से डिसाइड हो रहा है. और सीपीयू शेड्यूलिंग की प्रोसेस ये कौन एग्जीक्यूट, ये प्रोसेस कौन परफॉर्म कर रहा है, ये सीपीयू शेड्यूलिंग कर कौन रहा है, सीपीयू को शेड्यूल कौन कर रहा है, टीचर को शेड्यूल कर कौन. ऑपरेटिंग सिस्टम इज शेड्यूलिंग दी performing the CPU scheduling. Operating system is performing this task. Okay, so let me look at the chat box. So before moving on, let me see what this YouTuber is saying. Only 2 months are remaining. Can I get rank under 2000, sir? I only studied C, DS, Algo, not any other. Please tell sir, is it possible to complete remaining topics? If you have only 2 months with you, and whatever you have covered till now, revise that thing. Make sure that you can attempt all the last 30-year question from these subjects. You have mentioned that, okay, you have completed C, data structure, algorithm, and maybe any other subject if you have completed. So you just make sure that you will 100% solve the question from this subject. Okay, one thing. And other thing what you can do, rather than moving now to all the subjects, that is not possible, practically not possible. What you can do, just complete the most important topics from these subjects. Just complete the most important topics from all the subjects. Okay, and you have a good luck. Actually, we are covering in this course, in this gate crash course, we are covering most important 5 topics from every subject. Okay, so you take these 5 topics, you at least you will be knowing the name of these 5 topics, and if you want to learn from here, you can learn from here. Definitely you will get help. Otherwise, finish these 5 topics in its entirety and solve all the 30-year last 30-year gate question from these 5 most expected topics. Okay, so what I'm trying to say you that which subject you have completed, again revise that subject, finish that subject, and new subject please don't touch right now. For this year, please don't touch the new subjects. There will be no benefit. What you can do from other subjects, rather than studying them completely, study only the important topics which are most expected topics for gate 2023. Study only most important topics which have high probability that they will ask question from these topics. How you will get these topics? In this series you can find out, gate crash course series. You can find out in the description that detail about gate crash course. There they you will go to the Geeks for Geeks web page of gate crash course. You will find out the most important 5 topics from every subject with schedule, actually schedule of this great gate crash course. So complete these important topics, okay. And no, I'm not telling just because of this great gate crash course, but this is what you have to do right now, okay. So this is my suggestion for you. So one more question. Let me take 1 or 2 questions and then we will move to the CPU scheduling. Nishant is asking, I am from mathematics and statistics background. That's great. And I get AIR 120 in GATE mathematics. I have completed algorithm and programming till now. What should I do? So I think means what are you targeting for? If you get AIR 120 in GATE, then Nishant, I think you have to go for, you have to apply for maybe you get IIT Bombay or IIT Madras or maybe IASC also, because you are from mathematics background. See, if you are from mathematics background, that is the edge you already have with you. And these institutions actually focus on research and they like the people from mathematics background, because all maximum research is based on mathematics. So you do not need to, I will say that. So what are you doing right now? What you want? You have to apply for that. That's it. Okay. One last question I'm taking from GATE aspirant. If half of the subjects have completed, then should one can take test series or not? Yes, definitely you can take test series. And what you can do is, half of the subjects you have completed, attempt the subject wide test of those half subjects at least. And for other subjects, try to attempt the question, and check out that, okay, where where you are lacking. Okay, at least complete the most important topics from the remaining. Same thing I'm saying to every people. Whatever you have completed till now, revise that. And what is left, don't please pick all the subjects now. That will not be possible to complete right now. What you can the best thing you can do is complete the important topics from remaining subjects which you have not touched right now. So take the 5 most important topics from there. You can take the test series. That will definitely benefit you. Okay. So let's start with now CPU scheduling. So there is some terminology. This is very important actually for to go with this lecture. So I'm discussing about this terminology. Please focus here. Okay, please focus here now. CPU scheduling, come at here now, everyone. So first thing is arrival time. Arrival time of a process. What is the arrival time of a process? Okay, so we will study, actually in terminology we will discuss various type of time related to a process. Okay, how much time a process, at what time the process comes inside the system, how much time the process need to execute on the CPU, how much time maybe that don't get the CPU, that is waiting for the CPU. So there can be different time for a process, when the maybe a process completion time, process completed its task. So these times are required. Actually we need to these times will tell us, okay, what is the performance of a CPU scheduling algorithm. We have lots of algorithm with us. We will study them, and we can check out the performance with this time actually. Okay, first time is arrival time. Arrival time is nothing when the process comes in the ready state, or if you don't know about ready state, when the process come inside the RAM. When the process comes inside the RAM, first time the process is coming inside the RAM, you double click on your game exe file, and that game program comes inside the RAM. So when first time that come inside the RAM, that is the arrival time of your process, that is the arrival time of your game. Game is a program. Okay, what is another? Completion time. When you exit, when you stop the program or your program complete execution, that go out of the RAM, that go out of the RAM, that complete it, that complete its execution. You close the game. Okay, that go out of your RAM, that completed. When your program complete execution, then that time is known as completion time of that process, completion time of that process. Okay, another one is the burst time. Burst time means how much time your process required to execute on CPU. How much time, how much CPU time is required by the process. CPU is executing all the processes. Okay, that is executing all the processes. How much CPU time is required? CPU time is required. That is the burst time. That's it. Next one is turnaround time. Turnaround time is actually turnaround time is when you actually this is actually completion time, when you complete the process minus completion time minus arrival time. That is completion time minus arrival time. Yes, that is completion time minus arrival time. Okay, when you complete the process and when you enter inside the system. Okay, okay, इसको हम दूसरे तरीके से भी समझ सकते हैं. मैं एक एग्जांपल से समझाता हूं आपको. इन टाइम को ये ऐसा ही है, इसको आप ऐसे रिलेट कर सकते हो, आप अपने से रिलेट कर सकते हो. एक स्टूडेंट है, जब उसने कॉलेज में एंटर किया, व्हाट इज हिज अराइवल टाइम? दैट इज हिज अराइवल टाइम. जब उसने कॉलेज में एंटर किया, कॉलेज के गेट में एंटर किया, अब वो कॉलेज के गेट से बाहर जा रहा है. जब वो कॉलेज के गेट से बाहर जा रहा है तो उसका कंप्लीशन टाइम, दैट इज कंप्लीशन टाइम. ओके, अब वो क्लास में बैठा है. जब वो क्लास में बैठा है, दैट इज मींस दैट इज एग्जीक्यूटिंग ऑन सीपीयू. तो जब वो क्लास में बैठा है, पढ़ रहा है, क्लास में बैठा है, दैट इज बर्स्ट टाइम. ओके, क्लास में बैठा है, पढ़ रहा है, बर्स्ट टाइम. टर्न अराउंड टाइम हो गया टोटल टाइम, जब वो उसने कॉलेज में एंटर किया था और जब वो कॉलेज से बाहर गया. कॉलेज में एंटर किया था. ओके, मे बी 9 PM पे उसने कॉलेज में एंटर किया था, 9 AM पे, सॉरी. एंड 12 नून में वो कॉलेज से बाहर चला गया. तो कितना टाइम हो रहा वो कॉलेज के अंदर? 3 घंटे वो कॉलेज में रहा. 12 - 9 3, 3 घंटे वो कॉलेज में रहा. दैट इज टर्न अराउंड टाइम. देखो, जो टर्न अराउंड टाइम है ना, वो बर्स्ट टाइम से डिफरेंट हो सकता है. दैट कैन बी डिफरेंट फ्रॉम द बर्स्ट टाइम. मैं कॉलेज में मैंने एंटर की, जब मैंने कॉलेज में एंटर किया और मैं कॉलेज से बाहर गया, जब मैं कॉलेज से बाहर गया और कॉलेज में एंटर किया था, उसका जो डिफरेंस है, दैट इज माय टर्न अराउंड. मैं घूम रहा हूं, कॉलेज में घूम रहा हूं. तो ये टाइम में ना 2 टाइप के टाइम आ जाएंगे. कौन कौन से टाइम आ जाएंगे? एक तो जब मैंने कॉलेज में एंटर किया था तो मैं कुछ टाइम तो क्लास में रहा, दैट वाज माय बर्स्ट टाइम. कुछ टाइम मैं क्लास में रहा, लेकिन कुछ टाइम मैंने कुछ लाइब्रेरी में टाइम स्पेंड किया, मे बी कुछ टाइम मैं कैंटीन में बैठा रहा, मे बी कुछ टाइम मैं पार्क में बैठ गया अपने फ्रेंड्स के साथ. तो देयर मे बी अदर टाइम्स ऑल्सो, मे बी. ओके, लेट्स कीप इट सिंपल. तो अगर मैं जो टर्न अराउंड टाइम है वो टोटल टाइम है जो मैंने कॉलेज में स्पेंड किया. ओके, उसमें से कुछ टाइम मैंने क्लास में स्पेंड किया जो कि मेरा बर्स्ट टाइम था, और कुछ टाइम मैं क्लास से बाहर रहा, दैट इज वेटिंग टाइम. मैं मे बी कैंटीन में रहा, ये कैंटीन वाला टाइम है. वेटिंग टाइम इज द कैंटीन टाइम, जो मैं कैंटीन में स्पेंड किया. तो मैंने 2 टाइम स्पेंड किए कॉलेज में. एक तो मैं क्लास में रहा, दैट वाज माय बर्स्ट टाइम, देयर आई वाज लर्निंग. और कुछ टाइम मैंने कैंटीन में स्पेंड किया, दैट वाज माय वेटिंग टाइम. तो ये जब मेरे को सीपीयू नहीं मिला, वेटिंग टाइम क्या है? आई एम वेटिंग फॉर द सीपीयू, आई डोंट गेट द सीपीयू, आई डोंट एंटर इनटू द क्लास, so I'm waiting for the CPU. This is waiting time. Okay, another one is, last one is response time, and I can say this is actually first response time. This is first response time. First response time is actually is that time when first time I get the CPU. पहली बार मैं क्लास में एंटर किया, मैं कॉलेज में आने के बाद मैंने पहली बार जिस टाइम क्लास में एंटर किया, पहली बार. ओके, मे बी मैं फिर क्लास से बाहर चला गया, फिर मैंने क्लास में आ गया, फिर क्लास से बाहर चला गया, फिर क्लास में आ गया. ऐसा यूजुअली हम करते हैं. तो जो पहली बार मैंने जब क्लास में एंटर किया था, दैट इज माय रिस्पॉन्स टाइम. रिस्पॉन्स मतलब मेरे को कैसा रिस्पॉन्स मिला, मैं जैसे ही प्रोसेस अंदर आई सीपीयू में, रैम में आई, उसको सीपीयू एक साथ ही मिल गया, दैट वाज नाइस रिस्पॉन्स, दैट वाज नाइस रिस्पॉन्स, दैट वाज, आई विल से दैट दिस सिस्टम इज वेरी रिस्पॉन्सिव। जैसे ही मैंने इसको क्वेरी पूछी, इसने एकदम रिप्लाई कर दिया। ओके, मे बी इसने मेरी पूरी क्वेरी रिजॉल्व नहीं की, पर इसने एक साथ रिप्लाई किया, एकदम रिस्पॉन्स किया। सो रिस्पॉन्स टाइम इज एक्चुअली योर फर्स्ट, वी आर टॉकिंग हियर अबाउट फर्स्ट रिस्पॉन्स टाइम। पहली बार उसको एंट्री करने के बाद गेट में क्लास में जाने को कब मिला, मे बी 5 मिनट के अंदर ही क्लास में पहुंच गया वो, मे बी उसको 1 आवर वेट करना पड़ा। ओके, मे बी उसको क्योंकि दूसरी क्लास चल रही थी ऑलरेडी वहां पर, तो वो एंटर नहीं कर सकता था, दूसरी प्रोसेस एग्जीक्यूट हो रही थी सीपीयू में, तो उसको सीपीयू नहीं मिल पाया। तो रिस्पॉन्स टाइम is the first response time, actually I'm talking about first time he is getting the CPU. Okay, so this terminology is very important actually, and you need to know about this. If any doubt in this, please ask me, because we are going to work on this. And if you understand, can you people tell me? So we already discussed that. Okay, turnaround time is the completion time minus arrival time. जब मैंने कॉलेज में एंटर किया और जब मैं कॉलेज से बाहर गया, उसके बीच का टोटल टाइम। ओके, ये टोटल टाइम हो गया उसके बीच के टोटल टाइम में मैंने आपको बताया भी था टोटल टाइम क्या होगा। जो उसके बीच का टोटल टाइम होगा ना, ये जो डिफरेंस होगा ना, ये बस टाइम और दूसरा कौन सा है, वेटिंग टाइम, ये इन दोनों का टाइम, ये या तो मैं क्लास में एंटर रहा या मैं कैंटीन में रहा बस, और मैंने कुछ नहीं किया, या मैं क्लास में रहा या मैं कैंटीन में रहा, ये मेरा टोटल टर्न अराउंड टाइम इसको बोल सकते हो आप। अदरवाइज आप बोल सकते हो कंप्लीशन टाइम माइनस अराइवल टाइम। ओके, तो मेरे को बता सकते हो वेटिंग टाइम के लिए, वेटिंग टाइम आप कैसे निकाल सकते हो? इफ somebody provide you turn around time, if somebody provide you turn around time and burst time, if somebody provide you turn around time and burst time, can you tell me the waiting time? Can you tell me the waiting time? Please write in the chat, please write in the chat. देखो ये जो सेशन है ना, मैं पहले बता दूं आप लोगों को, सीपीयू शेड्यूलिंग हर बार आ रहा है गेट एग्जाम में, मोस्ट ऑफ द टाइम, आई विल से मोस्ट ऑफ द टाइम, हर बार हर साल आ रहा है वो ये टॉपिक। और यहाँ पे हम इस सेशन में टोटल कंप्लीट कर लेंगे इस टॉपिक को, कुछ भी नहीं छोड़ने वाले यहाँ पर आप लोगों का रोल रहेगा इसमें। मैं एक क्वेश्चन ही करवा पाऊंगा एक एल्गोरिथम से, और ये श्योरिटी करने के लिए कि भी आपको क्लियर है, क्योंकि अगर मैंने बता दिया तो ये मैं बता रहा हूं आपको, फिर भी श्योरिटी नहीं होगी आपको क्लियर है या नहीं, जब तक आप खुद उसको अटेम्प्ट नहीं करोगे अगले क्वेश्चन को। तो मैं एक क्वेश्चन, नेक्स्ट क्वेश्चन, हर क्वेश्चन गेट से उठाऊंगा, तो वो क्वेश्चन आप लोगों को अटेम्प्ट करना है, तभी आप कॉन्फिडेंट हो जाओगे इसी लेक्चर के अंदर कि आप कोई सा भी क्वेश्चन आ जाए आप सोल्व कर लोगे। लॉजिकली समझ लो उसको, क्या बोल रहा है ये, क्या चीज है ये, बात खत्म बस। ओके, आप मेरे को बताओ वेटिंग टाइम कैसे निकाल सकते हो अगर टर्न अराउंड टाइम और बस टाइम इज गिवन टू यू। प्लीज राइट, waiting and response time is same. No, get aspirant, waiting time and bus time, waiting and response time is different. See, logically देखो, logically समझ के चलेंगे इसको हम। वेटिंग टाइम वो टाइम है जो मैंने कैंटीन में रहा, जो टाइम मैंने कैंटीन में स्पेंड किया, वेट करता रहा क्लास के लिए, मैंने कॉलेज में मैं कैंटीन में जितनी देर रहा ना, वो मेरा वेटिंग टाइम था। और रिस्पॉन्स टाइम जब पहली बार मेरे को क्लास में जाने को मिला, ठीक है। वेटिंग टाइम में भी वेटिंग टाइम ऐसा नहीं है मैं स्टार्टिंग में आया, देखो ऐसा भी हो सकता है, एक प्रोसेस है ना, उसको सीपीयू मिला, पहले उसको सीपीयू मिल गया, फिर हमने क्या बोला, भाई तुम सीपीयू से बाहर जाओ, अब दूसरी प्रोसेस आ रही है हाई प्रायोरिटी की, वो एग्जीक्यूट होगी सीपीयू पे, तो आप प्लीज सीपीयू से बाहर जाइए। तो आप वेटिंग टाइम में चले गए, आप कहां पे चले गए, वेटिंग टाइम में चले गए। फिर कुछ टाइम के बाद फिर आपको सीपीयू मिल गया, फिर कुछ टाइम के बाद फिर आपको सीपीयू मिल गया, ठीक है। अभी मैं पूछ रहा हूं, आप पूछ रहे हो मेरे से, सर क्या ये वेटिंग टाइम सेम है क्या जो फर्स्ट टाइम मेरे को सीपीयू मिला था? नहीं, दोनों अलग है। मेरे को जो मैं सीपीयू जो मैं पहले ही, जब जैसे ही मैंने कॉलेज में एंटर किया, मैं क्लास में पहुंच गया 9 AM पे, लेकिन उसके बाद 1 घंटे के बाद मेरे को क्लास से बाहर धक्के मार के निकाल दिया गया, और मैं 1 घंटा लगभग 10 से 11 कैंटीन में बैठा रहा, ठीक है, तो मेरा जो वेटिंग टाइम है 1 आवर का रहा 10 से 11 के बीच में, और जो मेरा रिस्पॉन्स टाइम था वो 9 AM था, दैट वाज दी 9 AM, माय रिस्पॉन्स टाइम वाज 9 AM। और जो ये मैं वेट करता रहा ना कैंटीन में बैठा हुआ, आई वाज एंजॉयिंग दिस टाइम, so this was the waiting time. These both are different, response time and waiting time both are different. And we also get the answer from Ravish. Ravish says that वेटिंग टाइम इज एक्चुअली टर्न अराउंड टाइम। जितनी देर मैं तफरी मारता रहा, कॉलेज में घूमता रहा, ये तफरी टाइम है, ये तफरी टाइम है आप लोगों का, या इस टाइम में तफरी मार रहे हो, ये टोटल टाइम है कॉलेज में रहने का। आपने बोला मैं जितने टाइम कॉलेज में रहा, उसमें से जितने टाइम मैं पढ़ा क्लास में बैठ के, उसको अगर मैं माइनस कर दूं, जितने टाइम मैं क्लास में पढ़ा बैठ के, और जितने टाइम टोटल टाइम मैं कॉलेज में रहा, इज इक्वल टू तफरी टाइम, जितना टाइम आप कैंटीन में अपने वेट किया। ओके, जितना टाइम आपने कैंटीन में वेट किया, तो बिल्कुल सही है। तो वेटिंग टाइम इज एक्चुअली टर्न अराउंड टाइम। टर्न अराउंड टाइम इज टोटल टाइम, गेट के अंदर एंट्री से गेट से बाहर जाने तक, और बस टाइम जितनी देर आप क्लास में रहे। तो तफरी वाला टाइम कौन सा हो गया? वेटिंग टाइम। कैंटीन वाला वेटिंग टाइम। ओके, some people are writing turn around time minus bus time is equal to tafri time. You are not allowed to write this. Okay, so Rohan is saying turnaround time is bus time plus waiting time. Actually turnaround time I cannot say like that, that's why I removed this term. कुछ और टाइम हमारा कहीं और पे भी जाता है, जैसे हम कॉलेज में एंटर करते हैं ना, और कॉलेज से बाहर जाते हैं, कुछ टाइम हम कैंटीन में रहते हैं, कुछ टाइम हम क्लास में रहते हैं, और कुछ टाइम हमें ना कॉलेज, कुछ टाइम ना हमें कैंटीन से क्लास में जाने में लग जाता है, कैंटीन से क्लास का जो डिस्टेंस कवर करने में लग जाता है। ओके, क्लास से कैंटीन में जाने में लग जाता है। ठीक है, कॉलेज में आप दो जगह पे रहे खाली, एक तो आप क्लास में रहे बस टाइम, और एक आप कैंटीन में रहे वेटिंग टाइम। आप सही कह रहे हो, इन दोनों का टाइम जो टोटल टाइम है वो टर्न अराउंड टाइम हो गया, पर और भी थोड़ा टाइम आप कॉलेज में लगाते हो, खाली क्लास में और वेटिंग में नहीं लगाते, खाली क्लास और कैंटीन में नहीं लगाते, आपको ना कुछ टाइम लग जाता है यहां से क्लास से कैंटीन तक जाने के लिए, क्लास से कैंटीन तक जाने के लिए, उस टाइम को हम बोलते हैं कॉन्टेक्स्ट स्विचिंग टाइम। अगर टेक्निकली बोले तो दिस प्रोसेस इज नोन एज कॉन्टेक्स्ट स्विचिंग, एंड दिस टाइम इज नोन एज कॉन्टेक्स्ट स्विचिंग टाइम। तो यहाँ पे कॉन्टेक्स्ट स्विचिंग टाइम भी हमारा लगता है। ठीक है, तो एग्जैक्टली तो ऐसे बोलना पड़ेगा फिर आपको। ओके, अगर आप एग्जैक्टली बोल रहे हो। डिजिट इज आस्किंग व्हाट इज रिस्पॉन्स टाइम। भैया पहली बार जब मेरे को क्लास में जाने को मिला, वही मेरा रिस्पॉन्स टाइम है। ठीक है, पहली बार मे भी मैंने कॉलेज में एंटर किया, जाते ही मैं कैंटीन में बैठ गया, आराम से जाके जाते ही कैंटीन में बैठ गया, कैंटीन में 1 घंटा स्पेंड करने के बाद 9 से 10 बजे मैं क्लास में गया, तो मेरा रिस्पॉन्स टाइम हो गया 10। फर्स्ट टाइम जब मेरे को सीपीयू मिला, फर्स्ट टाइम जब मैं क्लास में गया, फर्स्ट टाइम जब मेरे को सीपीयू मिला, दैट इज माय फर्स्ट टाइम। फर्स्ट रिस्पॉन्स टाइम इज दी फर्स्ट, इसको आप रिप्लेस कर सकते हो, इसको ना रिस्पॉन्स टाइम, उन्होंने वर्ड लिखना ही नहीं चाहिए था ये बुक के अंदर, यहाँ पे ये लिख देते ना फर्स्ट रिस्पॉन्स टाइम, तो हमें ज्यादा क्लैरिटी आती है। फर्स्ट रिस्पॉन्स टाइम, पहली बार जब प्रोसेस को सीपीयू मिला वो कौन सा टाइम था, पहली बार जब सीपीयू मिला। उसके बाद मे भी मैं फिर कैंटीन में चला गया, मैं फिर मेरे को सीपीयू मिला, फिर मैं कैंटीन में चला गया, फिर मेरे को सीपीयू मिला, हो सकता है ऐसा, लेकिन पहली बार जब मेरे को सीपीयू मिला ना, पहली बार, फर्स्ट, यू प्लीज राइट इट हियर, फर्स्ट रिस्पॉन्स टाइम, पहली बार जब प्रोसेस को सीपीयू मिला। यस रोहन, टर्न अराउंड टाइम, टर्न अराउंड टाइम क्या हो गया? टर्न अराउंड टाइम इज दी कंप्लीशन टाइम माइनस अराइवल टाइम, जब मैं कॉलेज से बाहर गया माइनस जब मैं कॉलेज में आया था, टोटल टाइम जो मैंने कॉलेज में स्पेंड किया। ओके ओके, सो लेट्स मूव ऑन। आई होप दिस इज क्लियर, इवन दिस इज नॉट क्लियर डोंट वरी, बस आप लोगों को इतना ध्यान रखना है अभी के लिए, जो टर्न अराउंड टाइम है दैट इज कंप्लीशन टाइम माइनस अराइवल टाइम, कॉलेज से बाहर जाने और कॉलेज में एंटर करने का टाइम है। वेटिंग टाइम जो है ना, वो टर्न अराउंड टाइम, जो टोटल टाइम था कॉलेज के अंदर, उसमें से अगर मैं जो पढ़ने वाला टाइम है जो मैं क्लास में रहा बस टाइम को माइनस कर दूं तो मेरा वेटिंग टाइम मेरे को मिल गया, तो मेरा क्या मिल गया, वेटिंग टाइम मेरे को मिल गया। ओके ओके, तो अभी मूव करते हैं हम। सो व्हाट इज द गोल ऑफ सीपीयू शेड्यूलिंग? सीपीयू को शेड्यूल कर रहे हैं हम। सो व्हाट इज द गोल ऑफ द ऑपरेटिंग सिस्टम? द गोल ऑफ ऑपरेटिंग सिस्टम इज मैक्सिमाइज द सीपीयू यूटिलाइजेशन। ओके, सीपीयू को जितना ज्यादा बिजी रख सकें, सीपीयू को जितना ज्यादा बिजी रख सकें, दैट इज वन गोल ऑफ द ऑपरेटिंग सिस्टम। सीपीयू आइडल ना रहे। सीपीयू जो मैनेजमेंट होती है कॉलेज की, वो चाहती यही है, जो ऑपरेटिंग सिस्टम है वो चाहता यही है, को टीचर्स को पेल के रखो पूरा बुरे वाला, ठीक है। टीचर्स को खाली नहीं छोड़ना है, बच्चों को लोड करके रखो, ठीक है। तो टीचर खाली नहीं रहना चाहिए, टीचर खाली नहीं रहना चाहिए। मैक्सिमम यूटिलाइजिंग द सीपीयू, मैक्सिमाइज द सीपीयू यूटिलाइजेशन, और आई कैन से throughput of the system. I want to maximize the throughput of the system. Throughput of the system मतलब how many processes a CPU is executing in 1 unit of time. In 1 unit of time, और unit of time मतलब कुछ भी यूनिट ले सकते हो आप। मैं बोल रहा हूं 1 घंटे में मैं कितने बच्चों की क्वेरी को रिजोल्व कर दे रहा हूं, तो ये मेरी क्या होगी, थ्रूपुट। 1 घंटे में कितने बच्चों की क्वेरी को रिजोल्व कर दे रहा हूं। अगर मैं 5 बच्चों की क्वेरी को रिजोल्व कर रहा हूं और दूसरा टीचर 10 बच्चों की क्वेरी को रिजोल्व कर रहा है, उसकी थ्रूपुट ज्यादा है मेरे से। ओके, उसकी थ्रूपुट ज्यादा है मेरे से, क्योंकि मैं 5 बच्चों की क्वेरी को रिजोल्व कर पा रहा हूं। ओके ओके, सो थ्रूपुट को इंप्रूव करना और सीपीयू को यूटिलाइज करना, सीपीयू खाली ना बैठे। दूसरा गोल जो है ना सीपीयू शेड्यूलिंग का, वो है मिनिमाइजिंग व्हाट, टर्न अराउंड टाइम और वेटिंग टाइम। जो तफरी टाइम है ना आपका कॉलेज में, उसको मिनिमाइज करना चाहते हैं कॉलेज वाले। वो नहीं चाहते आप कैंटीन में बैठो। ओके, और जब वेटिंग टाइम डिक्रीज होगा, देखो ये तो टोटल टाइम ही है, ये तो टोटल टाइम है आपका कॉलेज में, ये तो डिक्रीज होगा ही होगा, क्योंकि ये इस पे भी डिपेंड कर रहा है ना, वेटिंग टाइम पे। आप लोगों ने मेरे को बताया था टर्न अराउंड टाइम जो है ना, वो वेटिंग टाइम और बस टाइम, ये 2 मेन बड़े फैक्टर हैं। ओके, कॉन्टेक्स्ट स्विचिंग टाइम भी कुछ टाइम लगता है इसके अंदर, क्लास से कैंटीन में, कैंटीन से क्लास का जो रास्ता कवर करने में टाइम लगता है, वो कॉन्टेक्स्ट स्विचिंग टाइम है, वो भी लगता है, ठीक है। लेकिन मेजर टाइम कहां लग रहा है, कैंटीन के अंदर बैठे हुए। ये कैंटीन में बैठने का टाइम अगर कम हो गया, इसको कम करना है। मैनेजमेंट क्या चाहती है, बच्चों का कैंटीन का टाइम खत्म कर दो, इनको बिल्कुल ही क्लास में बिठा के रखो। ओके, तो अगर ये कम होगा तो ये भी कम होगा, तो टोटल टाइम जो है आपका वो भी कम होगा, अगर हमारा वेटिंग टाइम कम हो गया। ओके, तो इनको दोनों को मिनिमाइज करना है अपने को, इन दोनों को मिनिमाइज करना है। कुछ भी क्वेश्चन आए आपके माइंड में, साथ के साथ वो आप चैट बॉक्स में डाल दो, ठीक है। पिछली स्लाइड से भी आए तो साथ के साथ आप चैट बॉक्स में डाल दो, so that we can take this query. Okay, so let's see various type of CPU scheduling algorithms now. What are the various strategies, algorithm to schedule the CPU? Operating system is scheduling the CPU. We have many processes is in RAM, like I'm playing game, I'm listening music also, that is another program. I'm coding also, that is another program I'm executing. I'm surfing internet, that is another program. So many processes are running in system. Which process will get the CPU? That is decided based upon different algorithms. So there are many different algorithms we will cover. Like first come first serve, जो पहले आएगा वो पहले पाएगा, जो पहला प्रोग्राम एंटर कर रहा है प्रोसेस रैम के अंदर, वही सीपीयू को पूरा एग्जीक्यूट करेगा, वो सीपीयू पे पूरा एग्जीक्यूट करेगा। शॉर्टेस्ट जॉब फर्स्ट, जिसका साइज कम है, जो कह रहा है मेरे को 2 मिनट लगेंगे मेरे को अपनी क्वेरी रिजोल्व करने में। एक बच्चा बोल रहा है मेरे को तो 10 मिनट लगेंगे अपनी क्वेरी रिजोल्व करने में टीचर से। तीसरा बच्चा बोल रहा है मेरे को 1 घंटा लगेगा, ठीक है। तो तीनों में से किसको टाइम पहले मिलना चाहिए, जो इसको 2 मिनट मिलेंगे। ये यही फॉलो कर रहा है। ये कह रहा है जिसको कम टाइम चाहिए सीपीयू का, वो पहले एग्जीक्यूट होगा, शॉर्टेस्ट जॉब फर्स्ट। ये बोल रहा है भैया जो पहले आएगा उसी को ही सीपीयू पहले मिलेगा, चाहे उसको 1 घंटा लगे चाहे उसको 10 घंटे लगे, वो पहले आया था उसको ही मिलेगा, बाकी को वेट करना ही पड़ेगा। ये फर्स्ट कम फर्स्ट सर्व, ठीक है। ओके, तीसरा जो है ना आपका शॉर्टेस्ट रिमेनिंग टाइम फर्स्ट, इसको हम बोल सकते हैं दिस इज एक्चुअली सेम एज SRTF इज सेम एज SJF, शॉर्टेस्ट जॉब फर्स्ट प्लस विद or I say with preemption, with preemptive mode actually, with preemptive mode. SJF with preemptive mode or SRTF, two different name of same thing. Okay, यहां से थोड़ी क्लैरिटी ज्यादा आ रही है, लेकिन शॉर्टेस्ट जॉब फर्स्ट ही हम एग्जीक्यूट करेंगे, यहां पे भी शॉर्टेस्ट जॉब फर्स्ट एग्जीक्यूट करेंगे, लेकिन यहां पे प्रियम्पशन अलाउड है। यहां पे क्या अलाउड है? प्रियम्पशन। सो व्हाट इज प्रियम्पशन? प्रियम्पशन क्या है? प्रियम्पशन क्या है? देखो, ये आपकी रैम है, ये आपकी क्या है? रैम। ये आपका सीपीयू है, ये आपका क्या है? सीपीयू। ओके, यहां पे कुछ प्रोसेसेस पड़ी हुई है, P1, P2, P3, P4। ओके, अभी क्या हो रहा है? P1 प्रोसेस यहां पे चली गई, सीपीयू पे अलॉट हो गई P1 प्रोसेस। P1 प्रोसेस सीपीयू पे अलॉट हो गई। कुछ देर एग्जीक्यूट करने के बाद ये बोल रही है नहीं नहीं, मेरे को तो वॉशरूम जाना है। मेरे को कहां जाना है? वॉशरूम। वॉशरूम मतलब इनपुट आउटपुट के लिए जाना है, इसको इनपुट आउटपुट के लिए जाना है। तो ये यहां से सीपीयू से यहां पे आ गई इनपुट आउटपुट के लिए। ठीक है, अभी ये यहां पे आ गई ना। ओके, तो हमने दूसरी प्रोसेस यहां पे अलॉट कर दी, P2, लेट्स सपोज P2 हमने यहां पे अलॉट कर दी। ओके, मीनवाइल P1 फील ये कंप्लीट करके वापस यहां पे आ गई, P1 यहां पे वापस आ गई। ठीक है, P1 यहां पे वापस आ गई। अभी क्या होगा? यहां पे हम प्रियम्पशन कर देंगे, यहां पे हम क्या करेंगे? प्रियम्पशन कर देंगे। P2 प्रोसेस को वापस रैम में डाल देंगे, भैया तुम वापस जाओ। ये प्रोसेस जो है ना, ये छोटी है, ये आपसे भी छोटी है। P1 को ना सिर्फ 2 ही मिनट चाहिए, पहले कुछ टाइम वो ले गई, अभी उसको 2 मिनट चाहिए। आप तो 1 घंटा मांग रहे हो, तो आप वेट करो, वापस जाओ। आप इस यहां से इस लाइन से वापस जाओ रैम के अंदर, और P1 को वापस लेके आओ। P1 को दोबारा फिर सीपीयू लोड कर दिया। तो हमने क्या किया? इस प्रोसेस को, किस प्रोसेस को? सिंपल, P2 को यहां से यहां लेके गए और P1 को यहां रैम से सीपीयू पे लेके आए। हमने प्रियम्प्ट कर दिया। हमने क्या कर दिया? प्रियम्प्ट कर दिया प्रोसेस को। एक प्रोसेस एग्जीक्यूट हो रही थी, सीपीयू पे एग्जीक्यूट हो रही थी, उसको धक्के से पकड़ के क्लास से बाहर निकाल दिया। उसको हमने धक्के से पकड़ के रैम में बिठाया। तू यहाँ वेटिंग, यहाँ पे वेट कर, रैम के अंदर वेट कर। एक P2 प्रोसेस आ रही है, वो पड़ेगी पहले। P2 प्रोसेस आ रही है, वो पड़ेगी पहले सीपीयू पे। तो ये इस प्रोसेस को हमने क्या बोल दिया? प्रियम्पशन। इसको हमने क्या बोल दिया? प्रियम्पशन बोल दिया। ठीक है, और एक इंफॉर्मेशन और आप नोट कर सकते हो, ये कौन कर रहा है? ये कर तो ऑपरेटिंग सिस्टम ही रहा है। ऑपरेटिंग सिस्टम का कौन सा पार्ट ये प्रियम्पशन परफॉर्म कर रहा है? So there is a short-term scheduler that is performing this preemption, तो preemption का मतलब मेरा सिर्फ इतना ही है, एक प्रोसेस सीपीयू पे एग्जीक्यूट हो रही थी, दूसरी प्रोसेस रैम में आई, उसको कम टाइम चाहिए था। उसको क्या वो कह रही है, जो सीपीयू पे एग्जीक्यूट हो रही है ना, जो सीपीयू पे एग्जीक्यूट हो रही है, उसको 1 घंटा चाहिए पूरा एग्जीक्यूट होने के लिए। और जो मैं नई प्रोसेस आई हूं अभी रैम के अंदर, मेरे को सिर्फ 2 ही मिनट चाहिए। आप प्लीज जो 1 घंटे वाली प्रोसेस है ना, इसको वापस रैम में लेके आओ, पहले मेरे को एग्जीक्यूट करो, क्योंकि आप शॉर्टेस्ट जॉब फर्स्ट एग्जीक्यूट कर रहे हो। प्लीज आप उसको प्रियम्प्ट करो, उसको रैम में लेके आओ, प्रियम्प्ट करो, और मेरे को सीपीयू को लोड करो, क्योंकि आप कौन सा एल्गोरिथम यूज कर रहे हो? शॉर्टेस्ट जॉब फर्स्ट, एंड आई एम द शॉर्टेस्ट हियर। आई नीड द स्मॉलेस्ट टाइम टू एग्जीक्यूट ऑन सीपीयू, so I will execute on the CPU. So this is known as preemption. Okay, this is known as preemption. तो ये हम स्टडी करेंगे यहां पर। ओके, ये हम यहां पे स्टडी करेंगे। अगला एल्गोरिथम कौन सा है? राउंड रॉबिन। अभी जितने भी ऑपरेटिंग सिस्टम आप यूज कर रहे हो, विंडो, यूनिक्स, लाइनक्स, जितना भी आप मैक, कोई भी ऑपरेटिंग सिस्टम यूज कर रहे हो, ऑलमोस्ट एवरी ऑपरेटिंग सिस्टम इज यूजिंग राउंड रॉबिन एल्गोरिथम फॉर सीपीयू शेड्यूलिंग। ओके, ऑलमोस्ट एवरी ऑपरेटिंग सिस्टम इज यूजिंग राउंड रॉबिन। इसमें क्या है? कुछ नहीं, सभी, मेरे पास 4 प्रोसेसेस है ना, सभी को मैंने 2-2 सेकंड दे दिए। लेट्स सपोज सभी को बोला, भाई तू 2 सेकंड तू ले ले, 2 सेकंड तू ले ले, 2 सेकंड तू ले ले, 2 सेकंड तू ले ले। फिर वापस फिर मैं घूम के आया, 2 सेकंड 2 सेकंड 2 सेकंड, सभी को 2-2 सेकंड हमने सीपीयू को लोड करते रहे, और ऐसे ही घुमाते रहे जब तक वो प्रोसेस कंप्लीट नहीं होगी। that is known as round robin. Another one is longest job first. ये एल्गोरिथम बोल रहा है, जिसको सबसे ज्यादा टाइम चाहिए वो पहले आओ, जिसको सबसे ज्यादा सीपीयू का टाइम चाहिए हम पहले उसको एग्जीक्यूट करेंगे। ओके, ये अपने ही नए रूल लेके आ रहा है। ओके, तो जो सबसे ज्यादा टाइम वाला है वो सबसे पहले एग्जीक्यूट होगा, फिर उससे कम, फिर उससे कम, फिर उससे कम, फिर उससे कम। ओके, नेक्स्ट एल्गोरिथम इज LRTF, लॉन्गेस्ट रिमेनिंग टाइम फर्स्ट, ये ऐसा ही है जैसे शॉर्टेस्ट रिमेनिंग टाइम फर्स्ट, मतलब इसको मैं दूसरा नाम भी दे सकता हूं, ये LJF ही है, लॉन्गेस्ट जॉब फर्स्ट ही है, लॉन्गेस्ट जॉब फर्स्ट ही है, बट विद प्रियम्पशन, विद प्रियम्पटिव मोड, विद प्रियम्पशन। ओके, प्रियम्पशन आप लोगों को पता ही है, अगर एक जॉब सीपीयू पे रन हो रही है, उसको 1 घंटा चाहिए एग्जीक्यूट होने में, दूसरी जॉब आ गई एकदम रैम के अंदर, दूसरी प्रोसेस आ गई रैम के अंदर, वो कह रही है मेरे को 2 घंटे चाहिए एग्जीक्यूट होने के लिए, जैसे उसने बोला 2 घंटे के लिए चाहिए, उसको धक्के से पकड़ के बाहर रैम सीपीयू से बाहर कर दिया और P2 को सीपीयू लोड कर दिया। तो इस प्रोसेस को हमने प्रियम्पशन बोल दिया। प्रियम्पशन हमने इसको बोल दिया क्योंकि हम कौन सा एल्गोरिथम यूज कर रहे हैं, जिसको ज्यादा टाइम चाहिए वही सीपीयू पे एग्जीक्यूट होगा, जिसको ज्यादा टाइम चाहिए वही सीपीयू पे एग्जीक्यूट होगा। तो इसके अंदर हम ऐसा कर रहे हैं कुछ। ओके, ये और ये सेम सेम, दो डिफरेंट नेम है सेम एल्गोरिथम की। नेक्स्ट वन इज प्रायोरिटी बेस्ड शेड्यूलिंग। अब इसमें क्या होगा, जिसकी प्रायोरिटी ज्यादा होगी, जिसकी प्रायोरिटी ज्यादा है उसको सीपीयू मिलेगा, जिसकी प्रायोरिटी ज्यादा है उसको सीपीयू मिलेगा। ये भी दो टाइप के हैं एक्चुअली, एक तो नॉन प्रियम्पटिव, जिसमें हम अगर कोई प्रोसेस एग्जीक्यूट हो रही है ना, एक प्रोसेस एग्जीक्यूट हो रही है P1 सीपीयू के ऊपर, उसकी जो प्रायोरिटी थी, लेट्स सपोज 5 प्रायोरिटी थी, उसकी एक नंबर दे दिया हमने, इसकी प्रायोरिटी 5 है। रैम के अंदर एक दूसरी प्रोसेस आई P2, एक नई प्रोसेस आ गई P2 रैम के अंदर, नई आई, अभी अभी आई है, उसकी जो प्रायोरिटी थी वो 10 हाई प्रायोरिटी थी, 10 इज ग्रेटर देन 5। ओके, सो उसकी प्रायोरिटी ज्यादा थी P1 से। ओके, लेकिन अगर आप नॉन प्रियम्पटिव एल्गोरिथम यूज कर रहे हो तो हम P1 को स्टॉप नहीं कर सकते हैं, हम P1 अपनी एग्जीक्यूशन पूरी करेगी, क्योंकि वी आर यूजिंग नॉन प्रियम्पटिव एल्गोरिथम। देयर कैन बी प्रियम्पटिव आल्सो, देयर कैन बी प्रियम्पटिव एल्गोरिथम्स आल्सो। तो इसके दो वर्जन है, एक तो नॉन प्रियम्पटिव, एक प्रियम्पटिव। ऐसे ही हम इसके भी बोल सकते हैं, इसके दो वर्जन है एसजीएफ के, ये नॉन प्रियम्पटिव है, नॉन प्रियम्पटिव है, और ये वाला जो है ना, ये एक्चुअली एसजीएफ का प्रियम्पटिव वर्जन है, एफजीएफ का प्रियम्पटिव वर्जन है। इसके अंदर भी ऐसे ही बोल सकते हैं, एलजीएफ के अंदर ये नॉन प्रियम्पटिव है, नॉन प्रियम्पटिव, और ये जो है ना, ये एलजीएफ का प्रियम्पटिव वर्जन है, प्रियम्पटिव। ओके, और ऐसे ही यहां पे ये प्रायोरिटी के भी नॉन प्रियम्पटिव और प्रियम्पटिव। प्रियम्पटिव में क्या होगा, अगर एक प्रोसेस ये एग्जीक्यूट हो रही थी सीपीयू पे, और जब ये एग्जीक्यूट हो रही थी सीपीयू पे, दूसरी एक नई प्रोसेस आई रैम के अंदर, उसने बोला आई हैव 10 प्रायोरिटी, उसने क्या बोला, आई हैव 10 प्रायोरिटी, यू हैव 5, प्लीज कम आउट ऑफ द सीपीयू, प्लीज कम आउट ऑफ द सीपीयू। ओके, सो ही विल कम आउट ऑफ द सीपीयू एंड ही विल गेट द सीपीयू। ओके, तो यहां पे हमने प्रियम्पशन परफॉर्म कर दी। So this can also be of two type. Okay, okay, okay. Hemant is asking for English. Okay, okay. So we have two or three. One thing is, I will continue now. Okay, in English. Okay, if you want me to proceed in English, one thing, and second thing is that, okay, gate aspirant is asking that we will discuss your point. Okay, we will discuss how SGF can be implemented. We will discuss when we will discuss this algorithm. I will come to this point. Okay, if I forget, please remind me again. Please copy paste the same statement. Okay, okay. So let's see different type of algorithms now. Next algorithm is HRRN, that is highest response ratio next. Okay, we will discuss this thing also. The main important point in HRRN is, this is actually very fair algorithm, very fair. Fair mean with what? See, you can see here, this algorithm is not fair. What this is doing is, if small process is coming, this algorithm is allotting the CPU to small process. And what the long will happen if a process is waiting for long time, because he required more time, that doesn't mean he have to wait for very long. See, I need 1 hour, a student need 1 hour for his to resolve his query, that doesn't mean he will wait till the end of the class. This should not be like that. So HRRN is taking care of this thing. He is saying that yes, I will give you, I will give priority to small processes. What this algorithm is doing, he is saying that how this is doing, we will discuss. We will do that thing. But what this is, he is saying that HRRN, if a small process is coming, small size process is coming who require less amount of CPU, I will execute that process first. Okay, but I will also take care of the long processes which require more CPU time and they are waiting for very long time. I will give preference to those also who are waiting from very long time. I will give to CPU to them, even though their space is still available. Because this person is waiting from so long, I will give time to this person also. So this is how HRRN is behaving. You will see this thing when we will apply this algorithm. Okay. And one query was here. One person was asking preemption. Yes, you were. I was coming to this. Mr. Black, I was coming to this. Don't worry. Okay. So you were asking what is preemption? What is preemptive? And this need to be clear. And you are right. Actually, this need to be clear because we have so many algorithms based on preemption. Preemption is nothing. See, preemption is what? See, I'm telling you. Right now, let me make some space here. This is our RAM. This is our RAM. In RAM, I have two processes, P1, P2. Let's suppose P1 on the basis of priority, I'm telling you. That can be on the basis of running time also. Okay. But priority, I'm telling. P1 priority is 5. P2 priority is 10. Okay, P1 priority is 5, P2 priority is 10. So I am allotting the process which is having higher priority to the CPU. So I am allotting P2 process to the CPU because that is having higher priority. So I pick the process from the RAM, I give it to the CPU. But while this process was executing, while P2 was executing, a new process enter inside the RAM. He is saying that my priority is 15. I am Rajnikant. My priority is 15. Rajnikant enter inside the RAM. And when the Rajnikant enter inside the RAM, this actor need to leave the CPU, that need to go back to the RAM. P2 will leave from here and come back to RAM, and P3 will come here. Why? Because the priority of P3 is 15 and priority of P2 was 10 only. We are using priority based algorithm. So we have preempted P2 from the CPU and allotted P3 to the CPU. This preemption, this process is known as preemption. This process is known as preemption. Okay. So in preemption, what I am doing, if high priority process comes inside the RAM, then I will pick low priority process from the CPU. I will put back it inside the RAM, and I will pick the high priority process from the RAM and put it inside the CPU. So this putting it here, P2 here and P3 here, this is known as preemption. I have done preemption. I preempted a process forcefully from the CPU and put it inside the RAM and allotted a high priority process to the CPU because I was using priority based scheduling algorithm. So I need to perform preemption here. Preemption is nothing. Forcefully a process is executing. He is saying that I need more time to execute on CPU, but you forcefully pick the process because that is having low priority and put inside the RAM and give the CPU to the high priority process. So this is known as preemption. That says preemption. We perform the preemption. Okay. So if still if you have any doubt, Mr. Black, if you have any doubt, you can ask me. Otherwise, we are moving on. Okay. That's great. You people are asking the doubts. Actually, you are helping other people also. Okay. You people are helping other people also, because the same doubt, whatever doubt you ask, the same doubt is remains in other people minds also. Okay. Okay. Another algorithm is the multi-level queue scheduling, in which we have multiple queues. We will see this algorithm. And another last one is the multi-level feedback queue scheduling. Okay. We will see this also. Okay. Okay, so these are the various algorithms. We will cover one by one. So let's start with the first one. First come, first serve. First come, first serve algorithm. Again, I'm repeating. I will solve one problem here. I will solve one problem. You need to be very careful. You need to see how I'm solving that problem. After that, I will give you one gate question. The gate question must be solved by you people. That must be solved by you people. Okay. If you will understand the thing, if you will not cram, then definitely you will be able to solve the gate question. Okay. Okay. So first comes first serve. Which process is coming first inside the RAM, that will first get the CPU. Okay, that's it. So here two things I will tell you for every algorithm. One is the criteria. Criteria means the criteria to select a process. Which process will go inside the RAM? Which process will get the CPU? So what is the criteria to select a process for the CPU? The criteria in first come first serve is arrival time. Arrival time. So who is coming first, who is arriving in the campus first, that will go to the class first. Okay. So who is coming late, then if the class is full, then they need to wait outside. Okay. So criteria is arrival time. And mode is non-preemptive. Non-preemptive means if a process is executing on the CPU, P1 comes and executing on the CPU, okay, and we cannot forcefully remove the P1 from the CPU. Okay, we cannot forcefully remove the P1 from the CPU. In first come first serve, even the P1 required thousands of seconds, thousands of hours to execute. He will first complete its execution. Complete execution he will complete. Then only the another process can get the CPU. Then only another process can get the CPU. So the mode is non-preemptive. Okay, the mode is non-preemptive. Now I'm taking first question. We will solve using. So I'm taking it from my notes actually. So I'm writing here. So let me write here, make a table here. So I'm writing three information here. One is process number about all the processes, their arrival time, and burst time, how much CPU time they need. Okay, so I have first process which arrival time is 6, that come inside the system at 6 unit of time, and that need 4 time at CPU. There is another process P2, process number is P2 process which come at second unit of time, and that required 5 unit on CPU. Like so on, we have many other processes, 4, 5, 6. I hope that is visible to you people. And here is the arrival time of them. The arrival time of P3 is 3, P4 is 1, P5 is 4, and P6 is 5. Okay, and the burst time is 3 here, 1 here, 2 here, 6 here. Okay, so this was the, we have 6 processes inside RAM. They comes at different unit of time, and they require different unit of CPU time. Okay, so we need to find out three things here. One is completion time of every process. Another one is turnaround time of every process, and one is waiting time of every process. Okay, these three things we need to find out. To find out these three things, actually we need to generate a Gantt chart. Actually we need to generate a Gantt chart. So with the help of this chart, I will get these three information. I will be able to find out these three information. What is the completion time of every process? What is the turnaround time? And what is the waiting time? Okay. Okay. So you people tell me, please keep helping me. Okay. Please keep helping me. I'm starting from zero time. I'm starting from zero time. At zero time, which process comes inside the system? Please keep helping me. Please keep helping me. Please be with me. Please tell me. So what is the at zero amount of at zero unit of time, which process comes inside the system? Please write in the chat. Please help me in this. We will work together on this problem. Which process comes inside the RAM at zero unit of time? Please write in the chat. Please write in the chat. P4 not come. P4 come at the first unit of time. P4 come at the first unit of time. No process come. No process come at 0th unit of time. Actually, the first process, this process, P4 process comes at first unit of time. At first unit of time, the P1 process come. At 0th unit of time, there was no process inside the system. There was no process inside the system. The CPU was idle. CPU was idle for, let's suppose, 1 second. I'm taking the time unit here second for understanding. Okay, otherwise that is not seconds. CPU execute the processes in nanoseconds. Okay, just for understanding, I'm using the unit seconds. Okay, so for first second, 0 to 1 second, for first second, CPU was idle. CPU was idle. P1 comes inside the system. Okay, at first unit of time. Okay, now P1 come, and according to first come first serve, who will come first? That will execute completely. Because we are using non-preemptive approach. So we cannot forcefully preempt him and give another process to the CPU. So how much time that need? This need 1 unit of CPU time. So at 2 unit of time, at second actually at 2 unit of time, P4 will complete its execution. Okay, now P1 actually comes inside the system. At second unit of time, which process is inside the system? Please write in the chat. Please keep writing in the chat. Which process comes inside the system? At second unit of time, which processes are inside the system? P4 is already completed. Okay, which process is inside the system? Please let me know. Which process is inside the system? Keep writing fast. Keep writing. 2. Second process, P2. P2 is now, arrival time of P2 is 2. So P2 comes inside the system, and P2 is the only process at second unit of time. All the other processes coming after P2. This process is coming at third unit of time. This process is coming at fourth unit of time. P6 is coming at fifth unit of time. P1 is coming at sixth unit of time. So P2 is coming at second unit of time, and that required 5 burst time. So give all of that time. So 2 plus 5 is 7. At up to 7 unit of time, P2 will execute. Up 7 unit of time, P2 will execute. Okay, so P2 finish, P4 finish. So at 7 unit of time, which process is inside the system? Please let me know which process is inside the RAM. Please write in the chat. Fast everyone, please fast. Which process is inside the RAM? Please write in the chat. I'm telling you, if you want, see these CPUs from CPU scheduling, most of the every year the question is coming. Most of the time, I will say every year the question is coming, and you will be able to solve all the questions. Believe me, right now you will solve the gate questions with me. But the only prerequisite is, please write in the chat. Please, right or wrong, please write in the chat. Right or wrong, that doesn't matter. Please write in the chat whatever you are getting. And Ravish is right actually. So now at 7th unit of time, see, this process comes at 3rd unit of time. This is 7th unit of time right now. Present time is 7. So P3 process is already inside the system. P5 is also inside the system. That comes at 4th unit of time. This process is also inside the system, and this process is also inside the system. All the processes are now inside the system. Okay, but which one will execute now? Which is coming first? Which come first? This P3 come first, as compared to, if you are comparing this this, and this. Okay, so P3 will execute next. How much time that required? 3 unit of time that required. So up to 10 that finish. After finishing this, which comes next inside the system? This one. This one come next inside the system, which is the P5 process. P5 process, how much time that required? 2 CPU time is required. At 12 that will also finish. After that, P6 comes inside the system at 5th unit of time. So P6 come and that required 6 unit of burst time. So that finished at 18. 12 plus 6 is 18. This also finish. After that, this process come at 6th unit of time at the last. So P1 will also finish the execution that required 4 unit of time. So this is actually 22. At 22, this will also finish. Now let me write this information also: completion time, turnaround time, waiting time. I'm calculating it only for one example. I will not calculate this thing for any of the further examples. For all the further examples, actually I will calculate this Gantt chart only. Okay, I will draw this chart only, and you people also will share this information only, because if you can make this Gantt chart, finding this information is very easy. You people already know. Actually, you people already know. Maybe I can erase this thing and make some space here. Okay, and you people already know how we calculate the turnaround time. Turnaround time is actually, maybe I can write here or maybe here. Turnaround time is actually completion time minus arrival time. And what is waiting time? We are calculating waiting time also. Waiting time you already know. Once we will calculate the turnaround time, then we can calculate waiting time. Waiting time is turnaround time minus burst time. ये तफरी time है हमारा. How much time we remain in the canteen? Okay, so I can write here also CT minus AT, and this is actually TAT minus BT. Okay, okay. और completion time कैसे find out करना है? देखो बहुत simple है. That is very easy actually. You just start from the back, move forward, keep checking. You get P1 first, so P1 completed at 22. P1 completed at 22. Next process you get P6. P6 completed at 18. Next process you get P5. P5 completed at 12. P5 completed at 12. Next process you get P3. P3 completed at 10. P3 completed at 10. Next process is P2. P2 completed at 7. P2 completed at 7. Next process is P4. P4 completed at 2. 2 unit of time. 2. That's it. Okay. So this is the completion time. So if you generate this chart, then finding this information is very easy. Now, what is turnaround time? CT minus AT. That's it. 22 minus 6 is how much? 22 minus 6 is 16. 7 minus 2 is 5. 10 minus 3 is 7. 2 minus 1 is 1. 12 minus 4 is 8. 18 minus 5 is 13. Simple. CT minus AT. That's it. And what is waiting time? That is also very easy. So turnaround time, we calculated turnaround time minus BT. 16 minus 4, 12. 5 minus 5, 0. 7 minus 3, 4. 1 minus 1, 0. 8 minus 2, 6. 13 minus 6, 7. Okay, so that's it. Now you add these numbers. In exam, usually they ask the average turnaround time or average waiting time. Okay, so if you will add all these numbers, you let me see directly, you will add all these numbers, you will get 50. Total will be 50 here, and here if you will add waiting time, total waiting time you will get 29. You will get 29. So average is how much? Turnaround time 50 divided by how many processes are there? 6 divided by 6. Okay, so this is actually 8.3. Okay, and what is waiting time? 29. 29 divided by 6. 4. I think 8. 4.8. Yes. So that's it. That's it. Any doubt you can ask. Otherwise, I'm giving you now a gate question. That question you need to solve yourself. And 70, I will, you need to follow the same procedure. I'm not telling you to follow some other thing, okay? But you need to be careful, okay? So let me go to the next slide. So actually, let me give the question on this slide, okay? Let me give the question. I don't want to erase all this stuff. Maybe you can ask the question here. So let me give the question for practice. That is important actually. This thing is important that you people try actually. Okay, this is the gate question I'm giving you now. Okay, please try if you can solve it or not. And what you need to share in the chat box, you just please share the Gantt chart, sequence of processes in Gantt chart. Okay, like maybe you can write idle, P1, P2, or maybe I don't know, P3, so on. You just write the sequence. Okay, whatever you get the sequence in the Gantt chart, please write that. So process number, arrival time, and burst time I'm providing to you. You need to give me the sequence of processes in the Gantt chart. Okay, so 1, 2, 3, 4, 5, 6 processes again we have here, and arrival time of P1 is 8, 3, 7, 10, 2, 3. Okay, and burst time is 4, 2, 6, 3, 1, 1. Okay, so let's see who will provide me this sequence in the Gantt chart. Please generate the Gantt chart for this using FCFS. So let's see if you can solve the gate question or not. Please try. That is important. You are trying or not, that is important. And if you are trying, then one thing is sure, we will finish this topic right now, which is one of the most important topic in from operating system, CPU scheduling. Every year question is coming. Please try. Please like the session also. If you think that this is beneficial for you people, please like it. Please give some time to like it. Please first like the session, then you can keep continue. So we already get one answer from Devanshu. Devanshu, nice to see you back. And I think you need to improve your answer also. Please try again. Sorry, Surat, we don't have classes for welder technician at GeeksforGeeks. So this is not the right channel for you. Divyanshu, please try again. See, same procedure I will follow. I'm not going to change anything. But this is gate question, so definitely they also know the FCFS is easy, but they will try to trick somewhere. That you need to be careful. They will definitely try to trick in every question. Even they are using the smallest topic, means FCFS we may find the easiest one, but they are tricking here also. That's why actually practice is required. Otherwise, we have already covered the FCFS. And I will use the same algorithm and solve this. So please try, keep trying. That is the only key. If you want me to solve this, you can ask that also. If you think that, sir, you please try, I can do that. But more important is that, believe me, that is the reality actually. More important is that you people try it. So, gate aspirant 23, you are right actually, but give the complete answer. Where is the process P1 and P4? You are right. Okay. So if you are trying, please try, keep trying it. Okay. You can put me on mute also. If you think that I'm disturbing you, please put me on mute. Keep trying. If you are trying, that is more important than whatever I'm doing here. Okay. So you can see this explanation later also in recorded lecture. Okay. So I'm trying here now. This is the same problem because we already get one answer. We already get one answer from gate aspirant 2023. So at 0th unit of time, our CPU remain idle because the first process actually come at 2nd unit of time. So for first 2 seconds, our CPU remain idle. Our CPU remain idle. Okay. And after that, this process comes inside the system P5. So that will finish its execution for 1 second. For 1 second, that is complete its execution. After this, which process is inside the system? Two processes are inside the system. Two processes are inside the system. Now, you can ask me one question, sir. We have two processes inside the system, which and two processes are coming at the same time. At the same time, two processes are coming at 3rd unit of time. Now, which will get the CPU? So, if arrival time is same, you can note down this point. If arrival time of processes are same, then we will pick next process. We will pick next process on the basis of process number. On the basis of process number, who is having the, if the arrival time is same, here 3 is there, so which is having the lower process number, we will pick that process. So P2 is the lower process number, so we will pick this process. One student asked me, sir, what about if process number is also same? Process number of two processes cannot be same. Process number is just like a roll number to a student. Okay. Process number of every process will be different. This is assigned by the operating system. Operating system is assigning a unique process number to every process. Okay. Even you can find out that in Unix with the PID command, process ID command, you can find out that. Okay. So if arrival time is same, you can check out for lower process number. So P2 have lower process number than P6. So I will execute P2 first. That required 2 unit of time. So at 5, that will finish executing. After that, I can execute P6. Okay, and that required 1 unit of time. So I finished this also. Okay, after this process, and this is also done. Now at here 6 will come. At 6 unit of time, actually you can see no process is there in the system. This process will come at the 8th unit of time. This process will come at 7th unit of time. This process will come at 10th unit of time. At 6th unit of time, there is no process inside the system. So CPU will remain idle for 1 second. For 1 unit of time, CPU will remain idle. At 2nd unit of time, P3 enter inside the system, and that is allotted the system. How much time that required? 6 unit of time that required. So 7 plus 6 is 13. Okay, so we're done with this. Now at 13th unit of time, I have two processes remaining. One is this process and one is this process remaining inside the system, P1 and P4. Which come first? P1 come first. So P1 will be allotted the CPU. How much time that required? 4 unit of time. So 13 plus 4 is 17. After that, I will finish this also. P4 process. how much time that required? 3 unit of time. So at 20 that will also finish. I hope you this is clear now. And does it also give the right answer? Ravish also give the right answer. Tech is writing. Okay. So that's great. You people are trying. That is great thing. That is required actually. So you solve this question yourself. This is the gate question, and that level is required. That's it. Okay, that level is required. So one important point, concept actually. So let me erase now. Erase this. Let me go back. Let me erase this also. Now we are talking about FCFS. Okay, we have solved two problems. One is gate problem. One is simple example, and there is one another concept in this actually, convoy effect. Convoy effect. This is one concept actually related to FCFS algorithm. What this concept says is that if a let's suppose there is a three processes comes inside the system, P1, P2, P3. So P1 comes at 0th unit of time, P2 come at first unit of time, P3 come at second unit of time. This is the arrival time. This is process number, and next is the burst time. So P1 is taking 100 unit of time, P2 is taking 50 unit of time, P3 is taking 2 unit of time. Okay, so now if we will make the Gantt chart of this, so P1 will execute first because that comes inside the system first. So for first 100 unit of time, CPU will be reserved for P1. P2 and P3 need to wait. Although they require very less time on CPU, they need to wait because of this. Okay, after that P2 will execute, and after that P3 will execute. Okay, so 107. So you can see here is that actually, if somebody asks you what is the response time, what is the response time of these processes, the response time of P1 is 0. Immediately P1 get the CPU. Okay, but what is the response time of P2? P2 only need the CPU for 5 seconds, but he get after 100 seconds. The response time of P2 is 100. What is the response time of P3? P3 response time is 105, even though he needs CPU for only 2 seconds, and he was present. Response time is actually, I will say, this present time minus the arrival time also. Okay, so minus 1. So this is 99 seconds. He need to wait 99 seconds before getting the CPU. Okay, he entered at first unit of time. After that, how much time he wait? First time he get the CPU after 99 seconds. Okay, and he get the CPU 105 minus 2. He arrive at 2. Okay, so he need to wait 103 seconds inside the system. First time he get the CPU for that. Okay, so the response time of these are very high. So so this is known as actually convoy effect. If a large process comes inside the system first and smaller processes comes inside the system later, then the response time of all other processes, I can say, will increase. The response time of all other processes will increase if one large process comes first inside the system. Okay, that will increase the response time of other processes. Okay, so this effect is known as the convoy effect. Okay, let me explain the same thing with one example. It's just like let's suppose there is a convoy of army, means army vehicles are going on. There is a complete army is going on some high altitude, maybe you can say, and there are lots of maybe you can say cars are there, tanks are there, and so on. So usually you will see that tanks move at the back. Okay, jeeps army jeeps remains in the front, then trucks will remain, then tank will be there. Okay, Why they are doing this? Because they know that tanks are slower than jeep and truck. Okay, if they will put the tank in front of the jeep, then their whole convoy will go slow, whole convoy will affect from that. Okay, so what they are doing, jeep is at the front because that can move fast than the truck, then truck, and then actually tank is going on. So this is actually the tank. So this is just like convoy effect. If they will put the tank at the front, so there will be a convoy effect. The whole the vehicles need to suffer. They all will need to go slow. They all need to go slow. Okay, so that is convoy effect that can happen inside this algorithm. This problem can happen inside the system if a high as if a process of high burst time is coming earlier inside the system as compared to other processes, then that will impact on the response time. And not only response time, that will also impact on the turnaround time and waiting time also. That will also impact on turnaround time and waiting time. You can check out this thing for turnaround and waiting time. You can take this example. You can calculate turnaround and waiting time. And let me give you another example also, P1, P2, P3. So let's suppose P1 comes at second unit of time, this come at first, this come at 0, and their burst time is 2, 5, and 100. So this is coming late now. This tank is coming late, then truck is coming, then car is coming. Car is coming going first. Now you can calculate the turnaround time here or waiting time here. The waiting time and turnaround time you can calculate. For this example, and for this example, you will find out that this is taking more turnaround time and waiting time as compared to this. So what I'm telling you is that due to convoy effect happens if a long process comes in the system first, and if you are using first come first serve, then convoy effect occur. Then all the processes response time will impact, their turnaround time will impact, their waiting time will impact. Okay. Yes, we are covering most important 5 topics GATE Aspirant 2023. After completion of this complete GATE crash course, I can plan for more any other second important topics we can try after these 5 most important topics. Any doubt you can ask. So we covered the first come first serve. Let's move to the next algorithm, that is shortest job first. The job which is having the less burst time, that will be given the CPU first. That's it. Okay, and here the criteria is the burst time. Criteria for what? Criteria for selecting a process for CPU. We are allocating the processes to the CPU, and that is selected based upon the burst time. If burst time is less, that will be assigned to the CPU first. Okay, and this is non-preemptive. SJF is non-preemptive. Non-preemptive means if the process is allotted to the CPU, even the more smaller process, even a more smaller process comes inside the RAM, but we will not preempt a process which is already executing. We will not forcefully preempt that. So that is not allowed in SJF. That is allowed in second version of SJF. That is actually SRTF. That is SRTF. In that preemption is allowed. See, in that preemption is allowed. But right now, we are talking about SJF, shortest job first, in which preemption is not allowed, non-preemptive. If a process is executing, we will not disturb, that will complete execution. Then we will give the next smaller process. Which required less burst time. Okay, again, I will take one example from my side. I will solve one example from my side. Another question again from the GATE, and you people will solve that question. So let me take one example from my side. Let me explain SJF. So see, they will ask you to calculate waiting time, turnaround time, and completion time. Okay, I'm not calculating that because that is very easy to calculate completion time, turnaround time, and waiting time now. If you can generate the Gantt chart, then you can solve the problem actually. So we will generate the Gantt chart here. That's it. If you are able to generate the Gantt chart properly, means you can solve the problem. Okay, so I will not calculate the completion time, turnaround time, waiting time. You can do that yourself. Important part is if you can generate the Gantt chart, you can solve the problem. That is clear. This is burst time. So I'm taking one example. These are the processes: 1, 2, 3, 4, 5 process we have. Arrival time is 1, 2, 3, 4, 5. The arrival time of P1 is 1, P2 is 2, P3 is 3, and so on. And their burst time is 7, 5, 1, 2, 8. Okay, so this is their burst time. Now let me generate the Gantt chart based upon this algorithm, shortest job first. Okay, okay, you people please help me, you people please tell me at 0th unit of time which process is inside the system. Which process is inside the system? Please write down, please write in the chat. See, you need to be with me. If you want to understand, if you want to ensure that you want to definitely attempt the question from CPU scheduling, you need to be with me and you need to answer in the chat box. You need to answer in the chat box. So which process will be right or wrong will not matter at all. Which process is available in the RAM at 0th unit of time? Idle. Indu says idle. You are right, Indu, actually. And Divyanshu and Ravish and Tech and Gate aspirant, all you people are right. Actually, there is no process inside the system. The first process comes at arrival time of first process is 1 unit. At first unit of time, the first process come, the process P1 come. So system remain idle. CPU remain idle. That is the bad thing we can do. Okay, so at first unit of time, P1 comes inside the system. So no other process is there. So because no other process is available at first unit of time, all other process will come later on. So P1 come inside the system, and this is non-preemptive. So we will give P1 CPU to the P1, and P1 will complete its execution. So from 1 plus 7 is 8. Up to 8th unit of time, P1 will execute. Okay. So P1 finish its execution. So at 8th unit of time, you people please tell me which process is inside the system, which process is inside the RAM, which process is inside the RAM at 8th unit of time. Please write in the chat. Mac is also back. Welcome back, Mehak. So which process, see, listen my question carefully. I'm saying which process is inside the system, which process is inside the RAM at 8th unit of time. Listen my question carefully. Yes, Ravish. All the processes are now inside the RAM. All the processes are inside the RAM. The arrival time of last process was 5, and now the time right now is 8 o'clock in the night, and at the 5 o'clock all the students come. Okay, so all the other processes are inside the RAM. Okay, now which process to select, which process to give the CPU? That is based upon the burst time. Which is having the minimum burst time that will be allotted the CPU. All these processes are now inside the RAM. Okay, at 8th unit of time, but the process P3 is having the lowest burst time. So I will allot the operating system will allot the P3 to the CPU for execution. That will execute for 1 unit of time. So 8 plus 1 is 9. After P1, which process will execute? P4 will execute, because this is done. Out of 5, 2 and 8, 2 is the minimum. So P4 process will execute for 2 unit of time. So that is 11. Done. After that, P2 will execute for 5 unit of time up to 16. After that, P5 will execute for 8 unit of time. That is 24. That's it. This is the Gantt chart for using SJF for this problem. That's it. Any doubt you can ask. Otherwise, you people need to solve now a gate question. from this topic. I don't have anything to tell more about this algorithm, everything we have discussed, okay? But still, please be careful while solving the question. This is a gate question actually, okay? So please be careful. They're not asking anything different, but they will just give, they try to trick somewhere every time, okay? This is bus time. So I'm writing here 1, 2, 3, 4, 5, 6. 6 processes we have, and arrival time of, I'm writing here 6, 3, 4, 1, 2, 5, and bus time is 1, 3, 6, 5, 2, 1. Can you please draw the Gantt chart? Can you please share me the sequence of the processes for this question? If you are using SJF, please write in the chat. Please try. That is important. You are trying or not, that is important actually. That is the only thing will matter. That will create the difference. I will solve the problem. I have solved this problem so many times actually. Okay. That will not benefit you a lot. What will benefit, believe me, what will benefit? The reality is that if you are trying, that thing will only make the impact. That is the reality actually. I can show some impression on you by solving the question myself, taking tough questions and solving that in front of you people, make the great impression. But that is not going to help you people. Please try it and share the answer in the chat box. That's the reality actually. Please everyone, please write in the chat box. Try it. This is one gate question. If you can solve it, you have reached to that level. That's it. You will feel confidence if you will solve the question yourself. GATE aspirant 2023, please try again. Please try again. You are trying, that's great. That's great. Please try again. If I get one answer from you people, write one answer, I will start solving it. I will also start solving it, but I'm waiting for one right answer from you people. One right answer. Please try. If I am solving, that will not going to help you a lot actually. That will just give you idea again, but again you will get stuck somewhere. Once you will solve yourself this level of question, you achieve that level. That's it. You achieve the gate level. You feel confident. One right answer I'm waiting for. So we get one answer from Digit, and Digit is always right actually. Let me check out. Yes, he is right. Divyanshu, you are also almost right. Both almost right, both of you. I say, Divyanshu, you need to work on little bit more actually. Okay, so we get so many answer. One answer from Mac, and okay, let me try it now. Okay, so let me. So you write. Okay. Okay, so let me try it here. Almost everyone is right actually. So starting from 0, no process is there, remain idle. So if you are trying, the benefit is that you will understand it very easily. Okay, you will be able to understand all the thing very easily. Up to 1 unit of time, no process was there in the system. Now this process comes inside the system, P4 process comes inside the system. How much time that required is 5 unit of time. Give the 5 unit to P1. Say up to 6, this will execute, this finish execution. After that, at 6 unit of time, actually all the processes are now inside the system. All processes are inside the system, which is this is already done, which need less time. See, which need less time here. Now P1 and P6 need less time. Okay, so if bus time is matching, then you need to check for what? If bus time is matching, 1 is matching, you need to check for the arrival time, lower arrival time. Who come first, that will get the CPU. If arrival time is also matching, please check for the process number, and process number is sure that that will not match. Okay, so if bus time is matching, check for the lower arrival time. If arrival time is also matching, please check for the process number. So here bus time is matching, I'm checking for the arrival time. Arrival time of P6 is less, P6 arrival time is less, P6 arrival time is 5. So I will execute P6 here, and how much time that required? 1 unit of time. At 7, this will execute. This is done. Next smallest process, according to bus time, I'm executing. Next smallest process is P1. Execute P1 also for 1 unit of time. That is also done. Which one is next to smaller one? This one. So P5. Let's execute P5 to 2 unit of time. That is 10 here. Next one is this process, that is P2. P2 for 3 unit of time, 13. And then after that, this process, that is P3 for 6 unit of time, that is 19. That's it. That is 19. Okay. That is 19. Okay. Let's move on. Next algorithm is the SRTF. Don't write silly things in the chat box. Okay. Next algorithm is the SRTF, shortest remaining time first. So this is actually SJF only. This is SJF only with preemption. That's it. Two names to same algorithm. SRTF is actually same as this thing. SJF using preemption. Okay. So again, I will take one example, and I will solve one example here on the board, and next gate problem I will give to you. And let me tell you one important thing. This is the most important algorithm from gate point of view. Many questions you will find out from SRTF. They are asking the question from SRTF, or second algorithm they are using is round robin. Okay, in CPU scheduling itself, these are the two algorithms which are most important. So you will find out so many questions from this topic. Okay, I also have so many gate questions from this topic, but we will solve one only, that will be sufficient. If you can solve others also. Okay, so let me solve one problem from my side using SRTF algorithm. In SRTF, we will again select the shortest job, but we will use the preemptive approach. Means let's suppose P1 and P2 is inside the RAM. P1 required 5 seconds to execute. Burst time is 5 seconds. Burst time is 5 seconds. Here burst time is 10 seconds. So according to this SRTF, we will allot P1 to the CPU. We will allot P1 to the CPU. But let's suppose P1 is executing. Meanwhile, one another process P3 comes inside the system, which required only 2 seconds. Then what we will do? We will preempt. We can preempt now. In simple SGF, we were not preempting it. We were finishing the P1, then we were allotting the P3. Okay, but here we are using preemption in SRTF, shortest remaining time first. Then we will put it P1 here back, and we will put P3 here. Okay, so we will perform the preemption. Okay. So let me write one question here, and let me solve one question, and then next you can solve. One, 2, 3, 4, 5, 6. Arrival time is 0, 1, 2, 3, 4, 5, and bus time is 7, 5, 3, 1, 2, 1. Okay, so this is the question with us. Please see it very carefully. I already said that this is one of the most important CPU scheduling algorithm from gate point of view, and I will take only one example, this example. Next example you people need to solve yourself. I'm also saying that you need to be very careful. Okay, you need to be very careful while solving the problem. Okay, please look at here how this algorithm will work. Again, I will make only Gantt chart. Completion time, turnaround time, waiting time, you can solve it yourself. If you don't know, you can again go to first come first serve. From there you can understand, and you can apply here very easily. Okay, so at 0th unit of time, which process is inside the system? P1 is inside the system. Okay, see carefully. P1 is inside the system, but P1, I cannot complete the P1. Maybe while executing P1, some other process also come inside the system. So what I have to do right now is I will execute every process for 1 unit of time. So that I can check, is there any new process inside the RAM? If there is any new process inside the RAM, then I will compare. Do you have the lower burst time? If you have lower burst time, you please go to the CPU. I will again come back to the RAM. Okay. So for 1 unit of time, I will execute. I'm saying I will execute P1 for 1 unit of time. Now the burst time required for P1 is 6 now. 1 unit of time I executed P1. At first unit of time, see, now 2 processes are inside the system. These 2 processes are now inside the system. 0 and 1, first and 2. These 2 processes are now inside the system. Which is having the lowest burst time? See, which is having lower burst time? 5. This P2 process is having the lower burst time. 5 is smaller than 6. So which process we will execute? P2 process we will execute, because that required 5 unit of time. P1 requires 6 unit of time. Again, I will execute for 1 unit of time. Why am I executing 1 unit of time? Because after 1 unit of time, maybe some other process also comes inside the system. Yes, another process is coming inside the system. At 2nd unit of time, P3 also entered inside the system. But I executed this process for 1 unit of time. Now burst time here is 4. Okay, this process I will keep repeating. That's it. See, now I have 3 processes inside the system: P1, P2, P3 at 2nd unit of time, 0, 1, 2. Okay, so which is required less unit of time, burst time? P3 required. Okay, so I will execute P3. Okay, for 1 unit of time I will execute. P3. So this is required now 2 unit, and at this time one more process enter inside the system. See, one more process inside the enter inside the system. Now P1 required 6 unit, P2 required 4 unit, P3 required 2 unit, P4 required 1 unit. So this is the minimum burst time. So I'm checking for the minimum burst time actually. So P4 again I will execute for only 1 unit of time. So that I can check, okay, if there any other process comes at the next unit of time. Okay, see, another process comes inside the system. This P5 comes inside the system at 4th unit of time. Now P1, P2, P3, P4, P5 are inside the system. Actually P4 has finished its execution, that is at 0, that has finished. Now competition is between P1, P2, P3 and P5. Which is the minimum? See, P3 and P5 is the minimum. P3 and P5 need the minimum burst time, but the burst time is same 2. If burst time is same, then I check for arrival time. If arrival time also same, I will check for process number. But let me check for the arrival time. So arrival time of P3 is less, so I will execute P3 for 1 unit of time. For 1 unit of time, I will execute P3. This is got now 1 unit of time. Okay. Now at 5th unit of time, this process also comes inside the system. All the processes now, see, now all the processes are inside the RAM. Okay. Now let me compare all of them. This requires 6 unit of time. This requires 4 unit of time. This requires 1 unit of time. This requires 2. This requires 1. So minimum is 1, and which is then they are same. So let me check arrival time. So P3 is having the minimum time. So I will execute P3 again. Okay. So P3 have completed. So at 6th unit of time. Okay. Once, let me tell you one line you can note down. After that, I will complete this algorithm actually. Before that, one more line you can note down. The line is that how this algorithm is behaving. I'm writing here how this algorithm is behaving. Actually, initially we were taking one step at a time. One step we were taking. One step we were taking. Until when we will take one step? Until all processes enter inside RAM, inside the system or inside RAM. All processes comes inside all processes arrival time reaches. Okay, and once all the processes arrival time reaches, means all processes are inside the RAM. When all processes are now have arrived, all processes have arrived, then what we will do? Then we will just simply execute this algorithm just like SJF. Simple SJF. Like we were doing in SJF, we will do like that. That's it. So now all the processes are inside the RAM. What we can do? Simply apply the SJF. So this requires 6 units of time, 4 units of time, 2 units of time, 1 unit of time. This requires minimum. So P6, give all the time. How much time required? 7. Done. According to this. And after that, out of 6, 4 and 2, P5 require minimum burst time for 2 unit. We will finish completely this. I'm not moving step by step now. Now we left with 2 more, 6 and 4. For P2 require less time, 4 unit of time. Give 4 unit. 13 will come here. That will be 0. P1 require 6 unit of time. Give 6 here, 19 at 19. This will also finish. Okay, that's it. This is how SRTF works. This is how SJF with preemption works. So any doubt you can ask. Otherwise, I'm going to give you one gate question. If you any doubt, please ask. Otherwise, I'm going to give you one gate question. Okay. So I'm writing the gate question now. So here is the gate question. Okay. So I will come to your question also, gate aspirant. Before that, let me write the question here and then we will discuss. Okay, then we will discuss about this point. So let me write the question here itself so that you can get the idea from here also. So let me make space here. Okay, I'm writing the question here. Process number, arrival time, bus time. So 1, 2, 3, 4, 5, 6 processes we have, and 3, this is the arrival time, 3, 4, 5, 2, 1, 2, this is the arrival time, and bus time is 4, 2, 1, 6, 8, 4. Okay, so this is the bus time. Please write the sequence of this Gantt chart. Okay, for this question. This is the actually gate question. So please try this yourself. Let's see if you can solve the gate question or not. Check it. Check if you can solve or not. And let me come to the question of gate aspirant 2023. He is asking about, okay, how SJF is possible. He is asking the question that, okay, let me discuss the question first. He is saying that SJF is working on the bus time. Whose bus time is less, that will execute actually. That will execute first. But actually, practically, we don't know how much the time a process will take. We cannot predict this thing. How we can predict this thing? How much time a process will take? Okay. So first thing I will tell you, I will give the answer like that. First thing is that you may use the SJF in those applications where you know already, where you are aware about the system. The system is very old. Every time the same type of processes is coming inside the system, every time the same processes are coming inside the system, and now you know which process will take how much time, which process will take how much time. You know this thing. Okay, they may come in different sequences, they may come, their arrival time may vary, but you know that, okay, you know that this process take 10 seconds, this process take 5 seconds, this process take 0 seconds, whatever second. Okay, so maybe you have predictable system like that. You may have this type of systems also. In this type of systems, there you can use this algorithm. One thing. Okay, second thing, even you don't know, even we don't know, what is the bus time of a process. Okay, this is practically almost in every system. There remains a new processes, we don't know about their bus time. How we can then compare which one is less, which one is more? For that, actually, there are some methods. Actually, we can make predictions. We can make some predictions. So let me tell you how you can predict. How you can predict. So let me give you one formula also. Maybe I can give you one formula for prediction of how you can predict how you can predict. You are predicting. You may not be right, but you are predicting. Based upon the predictions, you can actually find out how much a process will take time, how much bus time a process will take. Okay, let me write that formula. Maybe I can write it. Maybe I can write it here. So, okay. So this is the one formula actually used by the operating system to predict. Okay, how much burst time is taken by the, how much burst time is taken by n process. Okay, here Tn, this tilt Tn plus 1 is actually next expected burst time. Next expected burst time of a process. This formula can be applied on every process. Here, the major idea here in this formula is we have we want to find out the expected burst time of a process, okay, of n plus 1 time. A process is coming now n plus 1 time, that is coming back inside the system. Okay, so if that is coming inside the system at n plus 1 unit of time, so I need to find out, okay, how much time this process will take. I will say, okay, last time how much time this process take, last time when this process or this type of process comes inside the system, how much time that take. Okay, and what was my prediction about that? My prediction was right or wrong? My prediction was right or wrong? How much was my prediction? Okay, when that come at nth time, maybe that come last time when that visit, what was my prediction, and what was actual burst time? Based upon that, by taking a parameter alpha, actually this alpha is, we need to tune, operating system keep tuning it, keep changing it. Okay, every time he get the process, he match that. Okay, what was my guess and what was actually last time, I'm talking about last time at nth time, he know at nth time how much time a process, how much time the process take, he know this thing. So he will see that what was my prediction and what was actual burst time of that process. Based upon that, he keep tuning this alphabet, this alpha parameter, he will keep changing its value, varying its value. Okay, and after some time he will tune it properly, and his assumption for the next process, next time, for his assumption for the next time becomes very close to the actual burst time. Okay, by using this formula, that can do. Even in AI also, if you are machine learning student, you will find this formula very familiar, actually very familiar. In deep learning, we use this formula only to learn. As a human being, we also learn like this only. As a human being, we also learn like this. We make an assumption, we compare it with actual result. Whatever is the difference, according to that, we tune our parameters, this alpha in our mind. Okay, every time we keep modifying ourselves. We should not judge anyone, but this has become now our property. We start keep judging the people. Okay, if two faculty are coming on the same platform, then we start keep judging about them. Okay, so it's not like that. We start predicting, okay, this may happen, and after that we come to the actual thing that, okay, this is the reality. Okay, we start keep tuning our parameters. Okay, so this formula is used. Okay, you do not need to go in this. So meanwhile, we'll get answers also from Ravish and Digit. So let me check if you are right or wrong. So let me check it in my notes. So P5, P6, and after that P3 is coming at my end. P3, P2, P1, P4, again P5. So Ravish, your answer is matching with my answer, and yes, Ravi's answer is matching with my answer. Let's now solve this problem here. Okay, let's now solve this problem here. So let me erase this, make some space here. So let me make the Gantt chart here. So at 0th unit of time, there was no process. All people are right. And first process, this comes inside the system, and we give 1 second to this process to execute. So one unit of time I'm giving, until unless all processes comes inside the system. Okay, until unless all processes come inside the system. So this was the actually P5 process. P5. P5 comes for 1 unit of time. After that, at 1 unit, 2 more processes enter the system. Okay, 2 more processes enter the system, and which is having out of these, which is having the lowest burst time. So this P6 is having the lowest burst time. So we will give 1 unit of time only, 1 unit of time to this process, because still not all processes enter the system. I want to check if anybody else is there to enter inside the system. See, this also entered inside the system now. Now, out of 6, 7, 3, and 4, this 3 is the minimum. So again, P6 will execute for 1 unit of time. So at fourth unit of time, this process also enters inside the system. Again, 4, 2, 6, 7, 2. Which one is minimum? So 2 and 2 is minimum, because 2 and 2 burst time is matching. I will check for the arrival time. Arrival time here is 4, here is 2. So P6 again will execute. P6 have the lower arrival time, again for 1 unit of time. So at fifth unit of time, this process also enters inside the system. Now all the processes are inside the system. All the processes are inside the system. Simply execute this algorithm just like simple SJF. Okay. Now you do not need to worry. All systems are inside the RAM. All processes are inside the RAM. We do not need to worry now, because we know now the burst time of everyone. Nobody is going to come right now, and we do not need to move step by step, being very careful. We can just simply check out which is taking less time, burst time, and according to we can give the CPU. Okay, because nobody is new is coming right now. So here 4, 2, 1, 6, 7, 1. So 1 and 1 is minimum. Out of 1 and 1, which is having the lower arrival time out of these two. So P6 is having the lower arrival time. So we will finish this actually at 6. After that, we will finish this process. So make it 0. P3 process. This requires 1 unit of time only. After that, 4, 2, 6, 7. This is require minimum time. Make it 0. P2. P2 for 2 unit of time. Okay. And after that, 4, 6, 7. So this process we need to execute. That is P1 for 4 unit of time. And after that, 6 and 7. 6 is required. 6 is the fourth process actually. P4 that requires 6 unit. 13 plus 6 is 19. And after that, P5 that require 19 plus 7 is 26. 19 plus 7 is 26. Yes. So this is the solution for this, and you can check out this. You can try it. So I have many gate questions. Actually, you can check out the gate question yourself. There is a contest given in the description. In the contest, that is also free. The contest is related to this particular topic. There you can find out you can appear for the contest. There is a contest in every session actually. Every session there will be a free contest available for you people in the description. You can, after this lecture, you can attempt that contest also. Okay, that contest is actually help you to again attempt the gate level questions. Okay, so that is also free. You can attempt that gate contest after every lecture. In every lecture you will find out the contest. Okay, so I'm not giving you the more questions now on this, or maybe if you want I can give the question, you can attempt it later on. Two things we can do. Either we can move on, or so I think this topic is clear now. How SRTF works, this thing is clear. And let's move to the next algorithm. We don't have that much time. So you can check out the questions, or you can check out the question on internet. There are lots of questions already available. Next question is the round robin algorithm. Next algorithm is the round robin algorithm. So, okay. In round robin algorithm, that is also important one actually. And here in round robin algorithm, the criteria to select a process is time quantum. Here we provide a time quantum to every process. Okay, you will take every process will get 2 unit of time, let's suppose, or 3 unit of time. And P1 get 2 unit of time, P2 get 2 unit of time, P3 get 2 unit of time. Again, we come back to P1, P2, P3, again P1, P2, P3, like that. Okay, and we also check out their arrival time, because if they have not arrived, how we can assign the time quantum to them. Time quantum means how much time every process will get to execute on CPU. This is preemptive only. There is no thing like non-preemptive in round robin, because after every two unit of time we need to preempt the process and we need to give new process to the CPU. Okay, so let me take one example from my side, and then next example you people will solve yourself. So let me solve one example at my end. So process number, same thing, I'm writing arrival time and burst time. Okay, so 6 processes we have, 1 2 3 4 5 6, and arrival time is 0 1 2 3 4 and 6. Okay, and burst time is 4 5 2 1 6 and 3. Okay, this is the burst time. Okay, so let's apply the round robin. In round robin algorithm we use a queue also. We need to maintain a queue also. That queue help us to find out, okay, whose turn is this queue tell us who is next turn, who can execute on the CPU next. Okay, so let me execute it. Let me make the Gantt chart, and I will solve one problem only. Next problem, that will be gate problem, you people need to solve yourself. So at 0th unit of time, see carefully. Okay, one more thing they will provide is the time quantum. They will provide the time quantum in the question. Let's suppose the time quantum here is 2. The time quantum here is 2. 2 unit of time will be given to every process. So at 0th unit of time, P1 is inside the system. P1 is inside the system. So P1 is allotted the CPU for how much time? For 2 unit of time only. Okay. At 2 unit of time, these two processes also enter inside the system. Okay. So first of all, P1 is put inside the queue. We executed P1. While we were executing P1 up to 2 more processes enter inside the system, P2 and P3. So this is a queue. Actually, I'm putting the processes inside the queue, P2 and P3. So this is the front and this is the rear. I'm inserting from the rear. Okay. So after P1 get its chance for 2 seconds, he executed for 2 seconds, he will again come back inside the queue. He will come back inside the queue. He will come back and stand back in the line. Okay, he take its 2 seconds and come back, stand in the line, because he is saying that I have not completed yet, I need more time to execute. I executed for 2 seconds, but I need more 2 seconds to execute. So let me stand in the line. Okay, that's it. This is how this algorithm will move. Okay. So next process that will execute is the P2. P2 is in the front of the queue for 2 seconds, up to 4. Up to 4, 2 more processes enter inside the system. Which one? P4 and P5. So they are also enter inside the queue. P4 and P5 also inside enter the queue. Okay, and when P4 also completed its execution, P2 also completed its execution, he is saying that P2 is where? This one. So P2 is saying that I have not completed yet. I need 3 more seconds to complete. Let me stand back inside the line. Let me back stand inside the line. Okay. This process will keep repeating again and again. This process will keep repeating again and again. So next, the process in the front of the queue is P3. That will execute for 2 seconds, 2 unit of time. Up to 6, one more process comes inside the system. The process is P6. Okay, and P3 is this one, executed for 2 unit of time. That do not need more time. P3 do not need more time, so that will not stand behind the queue again. That do not need more time. Okay. So after that, P1 is standing in the front of the queue. P1 will get the CPU for 2 unit of time up to 8. Okay, and P1 will get the CPU for 2 unit of time. That's it. Okay, P1 do not need more. P1 do not need more CPU time, so that will also not stand behind the line now, because that needs zero unit of time now. Okay, this is done. Now P4 turn. P4 is in the front of the queue. Same thing I'm repeating for 2 seconds. This will execute. P4 execute for 2 seconds. Actually, P4 need only 1 unit of time. Okay, so we will execute it for 1 unit of time. Although he was having 2 units with him, but that doesn't mean we will wait for 2 seconds. Okay, we will give 1 second to it. This will complete its execution, and we will allot the CPU to someone else. Okay, P4 also don't need any more CPU, so that will not stand behind the line. Next one is P5. P5 is executing for 2 unit of time up to 11. P5 is this. So for that execute for 2 unit of time, that required 4 more, so that need to come back, stand in the line. P5. Okay, exit from the front and come stand behind the line, because that need more CPU time. Okay, after that P2 comes. P2 comes, again given 2 unit of time. P2 is this. He will require 1 more unit of time. He will again stand, I'm writing here, he will again stand behind the line. Go from the front and stand behind the line. Okay, after that is P6. P6 is this, that required 1 more unit of time. Again, that will also stand behind the line. After that come P5, same thing I'm repeating again and again. This is 15. For P5 required 4 unit of time, but we can give only 2 units. So 2 unit of time given, but P5 required more time. Please stand behind the line. Okay, next person in the front of the line is P2. We give the CPU to the P2. P2 required 1 unit of time only, 1 unit of time. So give 1 unit of time to P2. Okay, P2 is finished. That will not stand behind the line, because that required 0 unit only. Okay, after that P6, P6 require 1 unit of time. That also required 1 unit of time. Give 1 unit of time to P6 also. And P6 also will not stand behind now at the line. Okay, after that only one process left. Give all the time to this. So next time is P5, that is 21. That is at 21. Finish this. That's it. So this is how round robin algorithm will work. Any doubt, please ask. Any doubt, please ask. Otherwise, I'm going to give you one gate question now. If you have any doubt, please ask. So I'm writing the gate question here. I hope this part is visible to you people. And here is the question. Process number, arrival time, burst time. So we have 6 processes: 1, 2, 3, 4, 5, 6. Arrival time is like this: 5, 4, 3, 1, 2, 6. And burst time is like this: 5, 6, 7, 9, 2, 3. Okay, so please try this and share the sequence of the processes of Gantt chart in the chat box. If you can solve this question, you can solve every question related to round robin. This is actually also a gate question. And if you can solve this question, actually, you can solve every question related to round robin actually. Time, yes, the question is, what is the time quantum? That is a nice question. So the time quantum here is 3. Time quantum for this question is 3 now. Okay, time quantum for this question is 3. Definitely you have to ask. Indu is asking, Ravish is asking, Divyanshu, all. Uh, so the one thing is clear. I think the topic is clear to you people. Please try. If you can solve this question, that's it about round robin. Please try. Don't sit idle. That is the main problem. CPU should not be idle. So if I get one answer, I will also start solving the problem. If I get one answer from you people, and one more important question I will ask from round robin. But first, let me see if I can get the answer for this. If anybody is sitting idle, then I have one important topic question for you. You can tell me. The question is, let me write on the board so that other people can also get the question later on. So let me write the question. Let me erase this now. So the question is actually straightforward one marks question from round robin, and that is already asked in the gate also, and actually in ISRO also that is already asked, and even 2 or 3 times. Total 2 or 3 times they have asked the same question. And what is that question I'm writing here? And you need to think over the question and you need to give the answer. So if you are solving this question, please keep trying that. After that, you can come to this particular question. I'm writing it. The question is if we increase if we increase the time quantum, if we increase, or we say, okay, if we set the time quantum to a very large number, to a very large number then how round robin algorithm will behave. Round robin algorithm will behave. Actually, round robin algorithm will start behaving a totally different way. Totally different way if we will set the time quantum to a very large number. If we set the time quantum very large, then round robin will start behaving in very different way. So what is that way? You can think over it. Before that, Ravish already given the answer for this question actually. So if we have set the time quantum too large, then let's suppose for this question I set the time quantum to 10. If I set time quantum to 10, now every process will come and execute. Okay, the process who will come first, that will execute first. That's it. That will complete its execution. So if we set the time quantum more than the largest burst time here, even more than the largest burst time here, then the round robin algorithm will start behaving like first come first serve. Yes, get aspirant, you are right. It will behave like first come first serve. So any answer for that question so that I can move on? Divyanshu, I think you have shared this. Is this new one? Let me check. So any answer? So for this question, the answer is the round robin will start behaving like first come first serve. Okay. Okay, let's see this also now. How this will work. So then we will move to the next algorithm. This one is important one. So let's solve this problem. Round robin is important one. So we need to generate this Gantt chart, and we are using a queue also. So here at 0th unit of time there is no process, system remain idle. At first unit of time, the one process comes inside the system. So we give a time quantum of 3 to it. So P4 process execute for 3 unit of time up to 4. Okay, so P4 is inside the, we put inside the queue, ready queue, and execute it for 3 unit of time up to 6. So up to 4 unit of time, this process also come inside the system P5, P3 also come inside the system, and P2 also come inside the system. So let me write P5 come inside the system first, P5, then P3, and then P2. Okay, these comes inside the system while P4 was executing, but P4 need more time to execute, 6 more unit to execute. So that will come back, stand in the queue. Okay, that will come back and stand in behind the queue. Okay, now next process will execute P5. 3 unit we are giving to every process. P5 need actually 2 units only. P5 needs only 2 units. So why we have to give 3 units? So 6 will come here. What will come here? 6. We are giving 2 units to it. Okay, so 6 will come here. Now P5 is finished actually. P5 is finished. After that, actually, okay. When P5 was executing, P5 was executing, this process and this process also comes inside the system, P1 and P6. So let me put this also, P1 and P6 also come inside the system, because up to 6 unit of time these two processes also come inside the system. Okay, now this becomes actually very easy for us. Next process we'll execute is P3, and that will execute for 3 unit of time. 4 will be here, and 9 will be here, and P3 is not completed, that will stand behind the line. Next one is P2. P2 required how much time? 6. 3 unit of time he will get, so that will be 12. And P2 is not completed, P2 will also stand behind the line. Okay, and after P2, P4 will execute. So P4 require how much time? 6 unit of time, 3 unit of time he will get. So up to 15, P4 will execute, not finished yet, so that will stand behind the line. I'm not writing here, I'm writing here actually. Okay, after that P1 will execute. So P1 required how much time? 5. 3 unit of time he will get, so this will be 18, and P1 will again stand behind the line because that required more time. Then P6 how much time required? 3 unit, that is finished. So at 21 P1 will P6 will be finished, that will not stand behind the line because that is already finished. Then P3 how much time required? 4, but we can give 3 unit only, so 1 unit is still left. So up to 24 this will execute, and P3 again need to stand behind the line because he still need the CPU to execute. After the next process is P2. P2 require how much time? P2 require 3 unit of time, we are giving 3 unit. So at 27 P2 will finish, that do not require more time, that will not stand behind the line. Next one is P4. P4 will require 3 unit of time, so this will also not stand behind the line, finish it. Next one is P1. P1 require how much time? P1 require 2 unit of time, we can give 3, he required 2, give 2 unit of time to it and finish it. After that P3 require how much time? P3 require 1 unit of time, give it 1 unit and finish it. That's it. I hope this is clear. To you people. You can check out many questions on this in GATE exam. You can try that one. If you have any doubt, you can ask me, you can write in the chat. Otherwise, we are moving to the next algorithm, which is the longest job first. Any doubt you can ask? Clear? Okay, thank you for reply, Digit. So next one is the longest job first. That is easy one actually. That is easy one. Means if the longer job, if a process require more burst time, that will be given the preference. That is all based on the criteria is burst time. Mode is non-preemptive here. Mode is non-preemptive. That is very easy actually. So just for the sake of completion, I am taking one example, and we can do this. Not ask in the GATE anytime, and but still I'm completing it. That will not take more time. LRTF is little more important. From LRTF there are questions from LRTF, means preemptive version of LJF. So for that actually we need to understand this. For to understand that we need to understand this algorithm 0, 1, 2, 3 and 4, and here is 3, 2, 4, 5, 6. Okay, so simple. The job which is coming, which is the largest one, that will get the CPU. Which is coming at zeroth amount of time, this is coming. So give it the process P1. How much time required? 3. Give it 3 unit. Okay, at 3 unit of time, this one also enter inside the system. Which require more time? This P4 require more time, so give it the P4. Burst time, which is more, that will get the CPU. That's it. 3 plus 5 is 8. This is also done. Okay, and now this process is also inside the system. So out of 2, 4 and 6 is the largest burst time, so P5 will execute, and for how much time? For 6 unit of time. I think 14 will come here, and now we left with 2 processes, which is required 2 and 4 burst time. So P3 will execute for 4 unit of time and 18 will come here. Then P2 for 2 unit of time, 20 will come here. Yes, that's it. That's it. Okay. So I'm not going to give question on this, but let's move on. This one is important. This one is little tricky actually, and the gate people actually like the tricky concepts. This is the most trickiest one in all the algorithms, all the CPU scheduling algorithms. This is the most trickiest one. So if you will understand properly, then you will find that okay, you will be able to solve the question. That's it. Okay. So again, I will take one question from my side and one question from gate. I will give to you people, and even you can try it first yourself also. Then you will understand that okay, where the problem can occur in this. Because you understand this is using the longest job first, but here preemption is occurring. If longer job is coming, then we need to preempt the process. Okay, so just like SRTF, if shorter job is coming, we need to preempt. Here, if longer job is coming, we need to preempt. But this will behave slightly in different way. This will behave slightly in different way than SRTF actually. So I'm taking one example from my side. Next example you people need to solve. So 1, 2, 3, 4 processes we have. Arrival time is 1, 2, 3, and 4, and burst time is 2, 4, 6, and 8. Okay, so let's solve this question. Okay, actually this is itself is the gate question we are solving, and this is a nice example, that's why we have taken directly. This is itself the gate question. Okay, now we need to generate the Gantt chart, which is the most important part actually. So starting from 0, at 0 no process comes inside the system will remain idle, the CPU will remain idle for first unit of time. After that, this process comes inside the system, P1 comes inside the system. Now we need to execute it for 1 unit of time. We need to execute it for 1 unit of time. Okay, so that maybe other process comes inside the system which require more CPU time, then he will be given the CPU. So for 1 unit of time we are executing it, and yes, another process at second unit of time, another process also enter inside the system. So now we have 2 processes which require more CPU time. This require more CPU time. So we will give the CPU to P2 for 1 unit of time. For 1 unit of time we will give actually, maybe other system, yes, another process comes inside the system at this unit of time. Now we have 3 processes. One is required 1 burst time, one is required 3, one is required 6. So 6 is the largest one. So we will give the CPU to the largest one according to this algorithm. For 1 unit of time we will execute. Okay, for 1 unit of time we will execute. See if there is any other processes coming inside the system. Yes, P4 is coming inside the system. Then we will check all the 4 processes. Which is taking more time? P4 is taking more time. P4 is taking more time. Okay, then we will execute the P4. For how much time we will execute the P4? Can you tell me for how much time I can execute continuously the P4? For how much time? Think over this point. This point is a tricky one. This point is the most important one. This point is the most important one in this. If you can tell me for how much time I can continuously execute the P4, if you can tell me this thing, for P4 required 8 unit of time maximum. How you can write 12? How you can write 12? Okay, up to 12 you are saying. Up to 12 you are saying. Yes, you are right. Let's see if we can execute for up to 8. Actually, we cannot. We cannot. Sorry, digit, we cannot. And that's the trick here. That is the trick. This will come in everyone's mind that will go for 8 unit of time. Okay, but see here. We have 4 processes. One required 1 unit of time, one is 3, one is 5, one is 8. Okay, very simple otherwise. See, if I will take 1 unit of time from here, 1 unit of time here. That will be requiring 7 unit of time, still greater than all of them, all of these three. 6 still greater, 5. Now there is a comparison. Means for 3 unit of time, 3 unit of time means up to 7. Up to 7 I can execute P4, up to 7, 3 unit of time. For 1, 2 and 3 unit of time I can execute P4, but after that again the competition start. See, this process also required 5 unit of time. This process also required 5 unit of time. This process also will be compared, but these require less time. Now the P3 process will execute. P3 process will execute. Why? Although they are same, if burst time is same, then we check for the arrival time. If arrival time is same, then we check for the process number. But here you can see the arrival time of P3 is smaller than P4. So P3 will execute. For how much time P3 we have to execute? For how much time P3 we have to execute? Please keep writing. Please keep writing. Right or wrong doesn't matter. We are learning here. We are learning here. For how many time I have to execute P3? For how much time? 1 unit. Digit, you are right. For Divyanshu, you are right. I will come back to this. I already tell you that this is little tricky one. Don't worry, don't worry. This is easy also. Just need. I will take other example also. Okay. You please try to understand. I will recap. I will recap this thing, but let's move on. Let's complete it first. Try to understand here itself. Okay. So otherwise, I have done till now nothing. Up to when I was here at 4, let me repeat. When I was at 4, all the processes were in the RAM. Okay. This was requiring 1 unit time. This is required 5. This is required 3, 3, 5, and 8. 8 was the largest one. 8 was the largest one. I cannot completely execute P4 for 8 unit of time. Why? Because after 3 unit of time, the unit required, the time required for P4 is equal to time required by P3. Okay. After 3 unit of time. So I executed it for 3 unit of time. And now the time is same. Because the time is same, I will check for arrival time. Arrival time of P3 is less. So I start executing P3 for 1 unit of time. For 1 unit. Why 1 unit of time? Because now after executing 1 unit of time P3, now P5 is having more burst time. P5 require more burst time. P4 require more burst time. 5 is greater than 4. I need to execute P4. I need to execute them alternatively actually. They will go alternatively. For 1 unit of time I will execute it. Okay. Now I will execute again P3. Why? P3, although 4 and 4 is same, but arrival time is less here. So I will execute for 1 unit of time. Okay. So this will remain 3 now. Okay. Now this is having more burst time. Okay. So I will execute P4 for 1 unit of time. 1 unit of time. 3. Okay. Let me make some space here. Let me erase this. Let me erase this thing. Okay. Don't worry. We have other questions also. Many other examples also. Let's complete this first. Okay. So after this, see, after this, what is the scenario? P1 process required 1 burst time. This required 3 burst time. This required 3 burst time. This required 3 burst time. Which process I have to execute? Can you please write in the chat? Which process now I have to execute? Please write in the chat. Please try to write in the chat. Everyone, please try it. Which process I have to execute now? Please try to write in the chat. Everyone, please try. We have 4 processes, P1, P2, P3, P4. P1 require 1 burst time, P3 require 3 at this unit of time, P3 required 3 unit of, P4 required 3 unit. Which process I have to execute? Yes. Get the answer from Priyanshu, Digit, and Gate, Aspirant. P2 I will execute. This 3, 3, and 3, same burst time is same. I check for the arrival time. Arrival time of P2 is less, which is 2. So I will execute P2. I will execute P2 for 1 unit of time. I will execute. I need to execute for 1 unit of time because it's just like that. Okay. If I having more money, but if I will start spending the money, the one day will come that, okay, my money will be less than other people. Okay. And in that case, they will get more priority because they have more money. Okay. So I'm not allowed to spend all the money altogether, because they have given me one algorithm. They say that you can spend until unless you have more money than other people. Maybe this algorithm is generated by the parents also. Okay, they're teaching their kids that okay, you can spend the money, but until unless you have more money than other people. Okay, once you have equal money, then please check for the arrival time. Who is having the arrival time, that will execute it first. Okay, okay, so P2 will execute, and this will be 2 here now. Now which one will execute out of this and this? P3 will execute. So let me complete it now. After this, P3 will execute for 1 unit of time. This will be 2 here, and after that P4 will execute for 1 unit of time. This will be 14. After that again P2 will execute, then P3 will execute, then again P4 is execute, and after that 1 1 1 1. So all are same, so this is having the lowest arrival time. So let me write here. So P1 will execute, P1 is finished now, then P2, that is also finished, then P3, then P4. I hope this question is clear to you. I hope, please, if that is clear, please write in the chat. Please write in the chat if that is clear. If that is not clear, again you can write in the chat. Okay, please write in the chat if that is clear or not. Please write. So let me give you one question to try. This is also the gate question actually. I'm giving you right now. So let me make space here. Or maybe we can erase all. So let me make space here so that you can get some idea from this question. Erase. Let me make space here. Okay. Pen. Let me make a table. So this, try it, okay? Please try it. If you get the idea, then you can solve any question. And there is not a big deal here actually. Arrival time here is 0 for all the processes, and burst time is 2, 4, and 8. Can you please share the Gantt chart sequence of Gantt chart for all these processes? 3 processes are only there, 1, 2, 3. Can you please share the sequence in Gantt chart? Or Gantt chart, whatever you speak. Please try it and share the answer in the chat box. Apply the LRTF and share the sequence in the chat box. And after this, so I hope you have note down the question only. So Meanwhile, I'm writing the question for next problem, next algorithm, which is priority based scheduling. I hope you have noted down the question. If you have not noted yet, please take the snapshot. I'm moving to the next algorithm. Meanwhile, you are solving it and I'm writing the example for that problem. Okay. I hope you have taken the snapshot, and let me write the statement at least. And those who have solved it, previous one, they can try this one themselves actually. Okay. You people already get the idea now. So you can try this yourself. So who have solved the previous one? I will go back there, but meanwhile, let me write this. So meanwhile, you people are solving the problem. Okay, if you have already done Digit and Priyanshu, Divyanshu, sorry, you have done it. Let me see that is right or wrong first. So I'm getting the answer P3, P2, P3 again, then P2, P3, then P1, P2, P3, P1, P2, P3. So I was matching with the Digit. You are right. Let me check for the Divyanshu also. P2, P3, P2, P3, 2. I think that is same one. I think that is same one, or a little difference is there. Okay, I hope that is same only. So let me try this question now. We already get the answer from some of you. You, Divyanshu and Digit, you can try this question. You can take the snapshot if you want. You can try it yourself. Some priority is given, and this is priority based scheduling algorithm. On the basis of priority, we are assigning the process to the CPU, and this is non-preemptive. You can take the snapshot and you can work over it. Meanwhile, let me go back and solve this problem. Okay, and let me make some space here. If you people are trying, then that is more important than I will try it actually. So if you are trying, please keep trying. Okay, so let's make the Gantt chart here. So first of all the processes comes inside the system, which is taking the most highest burst time, P3. So assign P3 directly for 1 unit of time, because maybe that comes near to this. Okay, although you can directly put actually up to 4 unit, nobody is going to disturb the P3. Nobody is going to disturb the P3. When P3 will come at 4 burst time, then there will be a comparison here. Okay, so directly you can write 4 here, or you can write P3, P3, P3 4 time, whatever way you are finding easy. So if you understand, okay, that up to 4 unit, nobody is going to match with this P3, because that will be greater than all other else, you can see. So directly you can execute. Okay, and after that these both are same, but arrival time is also same now, but you will check for the process number. So process of P1 is smaller, P2 is smaller, so P2 will execute how much time? For 1 second. For how much time? 1 second you need to execute. So 1 second, and after that P3 again for 1 second, after that P2 again for 1 second, after that P3 again for 1 second. Now all are 2, 2, 2, 2. This is having the lowest process ID, So P1 will get the CPU for 1 second. Now P2 will get. Now P3 will get. Again 1 1 1. P1 will get. P2 will get. P3 will get. Okay, so this is the answer for this. We get some welcome message also. Okay, now let's move to the next question. I hope this is clear to you people. So the next algorithm is the priority based scheduling. In priority based scheduling, actually they are providing us the priority. They are providing us the priority of every process. Here we are assuming that 7 is the highest priority. The larger the number, the larger is the priority. And here 1 is the lowest priority. Okay, but that can be reversed also. In exam they can give you, they can say that if 1 is the highest priority and 7 will be the lowest priority. Higher the number, lower will be the priority. Lower the number, higher will be the priority. This can also happen. They will mention that in the question. But here the priority of higher number is high, lower number is low, so that we can easily solve the question. Okay. So we need to again make the Gantt chart, and CPU will be allotted based upon the priority, and this is non-preemptive. Once the CPU is allotted, we will not preempt it unless the process will not complete. So at 0th amount of time, that 0th unit of time, which process come inside the system? P1 come inside the system. How much time required? 4 unit. Give complete 4 unit to P1. Okay, and at 4 unit of time, now this process, these 2 to 5 processes come inside the system. Now I need to check, okay, which one is having the highest priority out of 5 7 2 1. 7 is the highest priority. So this process, this P3 process will execute next for complete, that will finish its complete execution. Okay, this is done. This is also completed. After that, at 5th unit of time, this also come inside the system. So the processes left is P2, P4, P5, B6. What is the priority? 5 2 1 6. 6 is the highest priority. So I will execute P6 process next. How much time required? 6. So 5 plus 6 is 11. This is also done. Next highest priority is the 5 out of these. So 5 priorities of P2 process. And how much time required? 5. So this will be 16. 11 plus 5 is 16. This is also done. After that, priority out of these 2 is more, and P4 process is that. How much time required? 2 unit. 16 plus 2 is 18. That's it. After that, only one process left, P5. How much time that required? 3 unit. 18 plus 3 is 21. That's it. I hope this is clear. And so if you want, I can give a question also. Do you want a question from this topic for practice? From this algorithm? Clear. Okay, that's great. So we are moving to the next topic that is related to this only, priority based scheduling. If you even want the question, you can solve. If you can solve this question, this is also priority based scheduling, but this is preemptive. The mode is preemptive here. If high priority process come inside the system, then we need to preempt the process. Okay, so if this is little more trickier than previous one. If you can solve this one, you can solve previous one also. Okay, so one question I'm solving, next question you will solve here. Okay, so you can solve GATE aspirant 2023. You can solve the question this one. If you can solve this one, you can solve previous one also. That was just like a warm up for this algorithm. So let me write the priority, process number, arrival time, and burst time. So 5 2 6, 4, 7, 8. These are the priority. Again, we are thinking that higher the number, higher the priority. So this is the highest priority. This is the minimum priority. Okay. And process number in the sequence 1, 2, 3, 4, 5, 6. And arrival time is 1, 2, 3, 0, 4, and 5. Okay. And bus time is 4, 5, 6, 1, 2, 3. Okay. Okay. Now I will solve one problem. Next problem you people need to solve yourself. Okay. 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 So let's make the Gantt chart. Starting from 0, which process comes inside the system? This one, P4 process. Okay. So we will execute this process actually for 1 unit of time. Why? Because maybe I'm executing this process, some other process come inside the system. Although this require only 1 unit of time, this will finish its execution. At 1 unit of time, this process also come inside the system. So that only one process is there. You do not need to check priority when one process is there only. Okay. So this require 4 burst time. I will execute it for 1 unit of time. P1. P1 process is this for 1 unit of time. Maybe at 2 some other process come inside the system of higher priority. So one more process come inside the system. This is finished. This process is finished already. So 2 processes are there now in the system. One is P1, one is P2. And which is having the higher priority? This 5 is more than 2. So P1 will execute for next unit of time. Okay. For 1 unit of time I'm executing. Why? Because maybe next third unit of time some other process also come inside the system which is having the higher priority, and that happens. The nightmare comes true. 6 is the higher priority than 5 and even then 2. So which process will execute now? P3 will execute. P3 will execute for 1 unit of time only. Maybe at 4th unit of time some other process come inside the system. At 4th unit of time this process come inside the system which is even having the higher priority, more higher priority. So P5 is having the higher priority than all of previous which are already inside the system. Again I will execute for only 1 unit of time to check out if at 5th unit of time some other process comes inside the system. Yes, this P6 process comes inside the system and that is having the highest priority. So P6 will execute. Okay, for 1 unit of time I can execute it actually. I can execute it for 1 unit of time, or maybe now see, maybe here now this is just like SRTF. Now all the processes, once all the processes are inside the system, their priority not going to change. Their priority is not going to change. This is always will remain the highest priority. Otherwise what I can do, I can execute one by one second to this, like this. Like this I can execute, or I can, what I can do, I can directly execute this complete process. Why? Because I know that this will remain the highest priority out of these. Okay, so I can directly write 9 here. Okay. Okay, so this is also done. Now out of 7, 6, 2 and 5, 7 is the highest priority. So P5, we will complete this process. Now we will complete all the processes. 10. Next highest priority is 6. Out of 6, 5 and 2. So P3 will execute, complete this process, because this will always going to remain, the priority is always going to remain highest out of these 3. So make it 0, add 5 here, 10 plus 5 is 15. This is done. Next highest priority is P1, that need 2 time, execute P1 also for 2 times, 17 will come here. This is also done. Now finish this also, that required 5 unit of time. So that is 22. That's it. Okay, I'll this will go like this only. Just I'm making a little correction here. 5 plus 3 is actually 8. 5 plus 3 is 8, not 9. Okay, so P6 will finish. Actually, I do not count this thing actually. I do not count this unit which I already taken. So 5 plus 3 is actually 8. This will be 8. One unit you need to, I'm just making a correction so that later you can verify this thing. This will be 14, this will be 16, this will be 21. Okay, why this happens? Because I added 6 plus 3, but I executed P6 one unit, then I added 3. No, I added I need to add in the 5. Okay, I need to add 5 into 3 actually. Okay. So one example for you people, one example now for you people, I'm writing here. You can try this. So priority, process number, arrival time, and burst time. Okay, so 4, 5, 7, 8, 5, 6. So this is 5. Okay, and process numbers 1, 2, 3, 4, 5, 6, and arrival time 1, 2, 2, 3, 3, and 4, and burst time is 4, 2, 3, 5, 1, 2. Try this and write the answer in the chat box. Please write the answer in the chat box. So you people are with me, still you people are with me. It's already 3 hours. So that's why I'm also continuing this session. So almost we have done. The next 2 algorithms are very easy actually. After this. So fast, come on, give me the sequence of processes in the Gantt chart. Meanwhile, you are doing this. I hope you have taken a snapshot of this. I'm writing. Thank you, Indu, for writing this thing. Thanks for appreciation. So I'm moving to the next slide. Meanwhile, you please take the snapshot, and I'm writing some information here about this algorithm. You please try that thing. Meanwhile, I'm adding some information so that we can use it. So any answer from previous one? This one for this example. So let me solve it at my end. If you are trying, please keep solving that. That is more important. Meanwhile, also let me try. Okay, so let me go it little bit fast way. Okay, you can please check out here. At 0, there is no process, so that will remain actually idle here. That will remain idle here. Okay, the CPU remain idle for 1 unit of time. After that, this process come inside the system. Yes, only one process is there, that is P1. Okay, and I need to execute it for 1 unit of time. And meanwhile, this process also come inside the system. So two processes are there. This is having the higher priority. So I will execute P2 for 1 unit of time, because maybe another process come at 3rd unit of time in the system. And yes, the third process also come inside the system, which is having even more priority, 7. So I will execute the more priority process, that is P3. Priority is 7. So 1 unit of time I will execute. So waiting for other processes, maybe other process come inside the system. Yes, even they have the higher priority. So P4 will be executed, that is having the highest priority out of 8, 7, 5, and 4. So for 1 unit of time only I will execute. So at 5th unit of time, one more process come inside the system, but the priority is 5 only. So still I will execute P4 only, because P4 priority is more than all the processes which already inside the system. So this will be 3, this will be 6 here, and after that this process also at 6th unit of time, this process also come inside the system, and this priority is 6. So now I simply, all the processes are inside the system. I simply will check out who is having the highest priority. According to that, I will completely finish that process. So like this process is having the highest priority, so I will finish this process. How much required? 3 unit more required. So P4 required 3 more unit. At 9 I will finish it. And after that, which is having highest priority, 7, finish this process, required 2 unit of time, give 2 unit to P3 and finish it. After that, this is the highest priority, required 2 unit of time, give it and finish it. P6 required 2 unit of time, finish it. After that, this is the next one, finish it, give 1 unit of time. P7, that is 14. After that, okay, here the priority was matching. Here the priority was matching. If the priority match, then you will check for the, if the priority match, let me verify, we will check for the bus time or the arrival time. Actually, we have to check for the, I think, bus time. Out of P2 and P5. Out of P2. So yes, actually we will check the bus time. If priority is matching, then check the bus time who required less time, and you can assign that. Okay, so if bus time is also matching, here bus time is also matching, then please check for the arrival time, who arrived first. So P2 was arrived first here rather than P5. Okay, so we executed this process, then P2 and P5 we were comparing, I think. So here P2 will come, that will finish, because the priority 5 and 5 is here. So this process will finish what? Why I am repeating again? Because the arrival time is less as compared to this. The arrival time is less as compared to this. Okay, so after that P5 process will complete, and after that this is complete for in 1 unit of time. This is also in 1 unit of time, and one process is left only, P1, and that required how much time? 3 unit, 18. Okay, I hope that is the right answer. Yes, that is the right one. After P1 and Gate aspirant is asking at 2 P3 have 7 priority after P2. So let me check out if I have done it right or wrong. So I think you people are right. You people are right. I make a mistake here somewhere. So what I can do better is, yes, you people are right. Gate aspirant, you are also right. So what I hope this is clear to you. The concept is clear, or we can do it again. And so that I'm sharing the answer. Okay, I'm sharing the answer now. The concept is clear. So first is idle is coming, and then P1, then P3, then P4, then P3, then P6. Yes, I make a mistake here. So based upon the priority we need to choose. I think I'd select P2, but that was P3. 7 was for P3. I write P2 here. Here I do something wrong. Okay. So P3, P6, P2, P5, and P1. I hope this will be your answer. Please check out P1, P3, P4, P3, P6, P2, P5, P1. Please check. This will be your answer. Okay, thank you, Gate aspirant, for replying. Okay, otherwise the answer is this. Please check out this. Okay, I hope the concept is clear. Yes, this is, I have made some mistake here. Please don't consider this. This is the answer for this question if you are looking at the recorded video. And the concept is same what I have done use here. Okay, the concept is same. I just swap some processes. So that this is the answer. You people can try. Okay. So next question, next algorithm is HRRN, highest response ratio next. Okay. In this, I have already tell you that this is very fair algorithm actually. If a process which is having the which required more burst time, that do not need to wait for long time in this. Okay. And the process which is required less burst time, that is also given the preference. Means this is taking care of both the people who require more burst time and the people who require less burst time. Okay. So actually in this how this algorithm works is, this algorithm use response ratio. Okay, based upon the response ratio, actually based upon the response ratio, the criteria is response ratio here. And this algorithm is also non-preemptive. Once the process is assigned, that will not taken back from the CPU. But the criteria is response ratio. Note down one point: response ratio is not same as response time. Response time is different term. Response ratio is different term. Response ratio is calculated with this formula. Okay, and this formula is actually helping this algorithm to remain fair with the big processes and as well as with the small processes. If how that remain fair with the big processes, if some big process is waiting for long time, then he will say, you please come first, I will give CPU to you first, as compared to even a new process is coming inside the system which required less burst time. So if some big process is waiting from long time, this formula will help that process to execute as compared to the smaller process. Otherwise, that is giving preference to smaller processes. But if somebody is waiting for long time, then that will say that, okay, you please come first. It's like that. Okay. So response ratio is calculated with this formula. What is this W here? W is the waiting time. What is waiting time? This waiting time is not same as WT. Please note, this is not same as WT. This waiting time is calculated with this formula. Present time minus arrival time. We already know about arrival time. I will tell you about the present time. Okay, I will tell you. What is this S? S is the burst time. We already know about the burst time. Burst time is also known as service time. Okay, how much service time required? Service time and burst time is same thing. So we know about burst time, we know about arrival time, but we don't know about present time. We will We will see what is present time here. This waiting time is not same as WT we discussing earlier. This W is actually this thing. This waiting time is calculated with this formula, and this response ratio is not same as response time. This is calculated with this formula. Okay, so with this criteria we schedule the processes. How? Let's see. So initially at 0th unit of time, one process comes inside the system, that was P1, allotted the CPU. This is non-preemptive. Once the process is assigned, that will complete its execution. Very simple. That will complete its execution. Look at it carefully. I'm not going to take more examples. Okay. Another one is that at 3 unit of time, now this process is also inside the system. All these processes are not still inside the system. Only P2 is also inside the system. So allotted P2 now. P2 also allotted, required 6 unit of time. We are at 9. Now you need to see carefully. Okay. At 9 unit of time, this process is completed. This process is already completed. These processes are now inside the system. P3, P4, P5 are inside the system. Only one. Now we will use the response ratio to calculate which process will execute out of P3, P4 and P5. Okay, so we need to calculate the response time for all the processes for P3, P4 and P5. Let me calculate for P3. So I'm using this formula. To calculate this, I need to calculate W, waiting time. For that I need present time minus arrival time. Arrival time is already here, but I don't know present time. This is the present time. This is known as the present time. At the time at which you are looking which process will execute, that time is known as the present time. So this is right now the present time is this. Present time is this 9. Okay. So what will be W here? Let me calculate. W will be 9 present time minus arrival time. Arrival time for P3 is 4. So that is 5. So let me calculate, put this W value now in this formula. So W is 5 plus what is the service time? Service time is the burst time. Service time is the burst time. Service time is this burst time. So plus 4 divided by again burst time. Again burst time. Okay, that's it. So 9 by 4, that is 2.2. Okay, so this is the response ratio of P3. Response ratio of P3 is 2.2. We need to calculate response ratio of P4 also, P5 also. What will be the response ratio of P4? I'm directly writing now. Same thing I will repeat. I need to calculate W first. W will be present time minus the arrival time. So 9 minus 6 will be 3, and let me put it in the formula, this to calculate the response ratio. So that will be 3 plus burst time, service time, 5 divided by 5. So this is 8 divided by 5. This is 1.6. Okay. Okay. So now I'm taking this space. For P5, let's calculate the W. W is what? Present time. Again repeating the same thing. Present time minus its arrival time. So 9 minus 8 is 1. We now have W with us. And what is the S? S is the burst time. S is the burst time. That's it. So 1 plus burst time is 2 divided by 2. So that is 3 divided by 2, 1.5. Okay. So now we have the burst time response ratio for P3, that is 2.2, for P4 that is 1.6, for P5 that is 1.5. Which is the largest one? This is the largest one. So P3 will execute. So the drawback of this algorithm is that to schedule one process, you need to calculate the response ratio of all the fighting processes. All the processes which are fighting now, which are present in the RAM, operating system need to calculate the response ratio. Okay, so all that need to be done. So how much time this will take? 4 unit. So up to 13 this will go. Now how many processes are in the RAM? This is also done. So two processes are there, these two processes. Again, we need to calculate what? Now you will start crying. You will say, again, we need to calculate the response ratio of P4 and response ratio of P5. Both these processes, which will be having higher response ratio, that will be allotted the CPU next. I'm directly writing what is their response ratio. You can calculate same in this way. You can calculate. I'm directly writing right now. So I have also not write it. So we can calculate, okay. So here W, what will be the W? Present time is now 13. 13 minus 6 is how much? 7. So 7 plus burst time is 5 divided by 5. So 12 by 5, 2.4. And what about this? Present time minus arrival time 8. So that is 5 plus what is the service time or burst time? 2 divided by 2. So that is 7 divided by 2. That is 3.3. So which is having the highest response ratio? P5. So P5 will get the CPU and complete its execution. 50. Now one process is left, so that will execute P4. So that will execute up to 5, up to over 20. So this is how the HRRN will work. If any doubt, please ask me in this. Otherwise, this is finished HRRN. And let me give you one question for your homework. You can try it. This is a good question actually from HRRN, and you can try it at your end. I'm not going to solve it because we already have taken so much time actually. So I'm giving you questions so that you people can try it. I will give you answer also, but in the comments, I will give the answer in the comments. Let me give you the answer question. Okay. Okay. So this is how we solve it. Now let me give you the question. So let me erase it. And let me give you the question from HRRN. This is a good question, actually nice question I'm going to share with you. Please try it and share the answer in the comment box. I will share the answer in the comment box from my end also. Once I will get one answer from one of you, I will share the answer. Everyone, please share the answer over there, okay? Okay, you people can try it and please share the answer in the comment box. I will share the answer also in the comment box, okay? Definitely visit. I will wait for your answer. And I will not share the answer unless you will not share the answer, okay? Okay, so this was the HRRN. Definitely you will be able to solve it. Next is the multi-level queue scheduling. That is very easy. In this actually we have multiple queues, multiple ready queue, I will say ready queue 1, ready queue 2, ready queue 3, ready queue 4. We can have many ready queues. And what we do in this algorithm is very easy. Listen, 2-3 important points about it, okay? First point, very important point. I'm not going to write, I'm just speaking. First point, the high priority, this is how this algorithm is working. This first thing is that this is having some ready queues, more than one ready queues that have this have, okay? What he is doing is, this algorithm is doing is, this is putting high priority process in the starting ready queues, okay? So these will execute first. The process which are in this ready queue will execute first, and the process with low priority will go to the next. More low priority will go to the next. More low priority will go to the next. And once the processes will finish here, then we will move to next processes which are here in this ready queue, waiting in this ready queue. That's it. That's it. This is multi-level queue algorithm works. Multi-level queue scheduling works. That's it. Have multiple queues, ready queues. Based on priority, we are putting the processes here. Once we will finish these processes here, then we will move so on. Okay. And one last point here is that the here ready queues, in different ready queues we can use different algorithms. Maybe I'm using here round robin for scheduling the processes here. Okay, based upon the priority, let's suppose some processes uh, having 10 priority. I have I have uh, I have many processes which is having 10 priority, or maybe some processes have priority maybe 10 to 20. So I put these processes here. Now after putting here, I'm applying round robin on these processes which is coming in this range. Okay, and every ready queue can have different scheduling algorithm inside. So maybe some other processes have 5 to 10 priority, so they are put it here, I put them here. After putting them here, I'm applying here some SJF. Maybe I'm applying SJF, or maybe I'm applying SRTF, or maybe I'm applying FCFS. So the important point here is that three important points are here. First, we are using different ready queues here. Based upon the priority, we are putting the processes in the ready queue. Higher the priority, I will put the process in higher priority queue that will be executed first. Okay, and after that, every ready queue can have its own scheduling algorithm to schedule the processes which are inside these ready queues. This is how multi-level queue scheduling algorithm works. That's it. Okay. Okay. Digit already shared the answer. Okay, so next algorithm is the multi-level feedback queue scheduling. Okay, so let me make a diagram here. Here also we have, this is the improvement over multi-level queue scheduling. Here we add one more word, feedback. Okay, maybe we can go back here and we can modify this itself. So you will be able to relate both of them, both the algorithm you will be able to relate. So next one I am talking about is multi-level feedback queue. Here one more word is added, feedback. So that algorithm is the improvement of this one. Okay, how they improve it? They put the processes here. Okay, and so here actually they also have the ready queues. Okay, what they are doing is, now here they have the ready queues. Okay, they have the ready queue. I'm starting right now. They have the ready queues just like previous one. Now they are inserting the processes here in the first ready queue, and they are saying that okay, the time quantum, the processes which are coming here, that will get the CPU for 2 seconds. If the process is able to complete in 2 seconds, that's fine. Otherwise, let me feedback the process to the next ready queue. Let's suppose we will set some time quantum here actually for every ready queue. Let's suppose I set time quantum here 4. That can change question to question. So the processes which do not complete it in 2 time quantum, they will be feed back to the second ready queue, and they will be given 4 more seconds to complete. If still they are not able to complete, we will feed back again into the next ready queue. There the time quantum I can set more bigger one. Okay, if still they are not able to complete, then again we will feed back to the last ready queue. There can be thousands of ready queue also, but the last ready queue, whatever will be the last ready queue, that will use FCFS. That will use first come first serve only. Okay, so now they are standing in the line. Even if they are not able to complete, they will stand in the line, and after that they will finish. Okay, so here you can see the arrows. The process will enter from here. Second thing, the process can exit from any ready queue because they can finish the in this time quantum. Maybe they can finish here itself. They require less than 2 time quantum. Maybe they can finish here, so they can go out. But if they require more time, they will shift to the next ready queue. And at the end, we are putting them into a queue FCFS form. They will definitely complete its execution here, turn by turn, and they will exit from here. One last important point about multi-level feedback queue is that here we are assuming that high priority processes need less time quantum. So here again, we are not thinking about putting the processes according to priority, but here we are assuming, by default we are assuming that if the process is of high priority, that will be requiring less time. Usually the people who have higher priority, they have less time with them, so they will execute fast. They must execute fast. So if high priority will be there, that will execute, that will be given the preference as compared to other processes. So this is just an assumption that high priority processes will take less time, okay, and they will execute earlier, so they will be finished in starting ready queue itself. Okay, so this is just an assumption in multi-level feedback queue scheduling. So that's it about it. You can check out the question. You can check out the question. I will, maybe if I get time, so I will share some question related to these scheduling algorithm. Otherwise, on internet you can check out. You will definitely find out, and you will definitely be able to solve them. One thing is sure. Last important point I'm telling you last related to starvation. Actually, what is starvation? First of all, if a process is waiting from infinite time, if a process is waiting, what is starvation? I'm telling you the definition, then I will ask you lots of questions related to starvation. If a process is waiting for very long time, he don't know how much time he need to wait. He don't know how much time he need to wait to get the CPU. If this thing is happening, then we say that starvation occur. I'm repeating the definition itself. The indefinite waiting of a process for CPU time is known as starvation. Let me write. So this is the last thing I'm telling you. Now I'm going to wind up all of them, all the algorithm. The indefinite waiting of a process for CPU time is called starvation. Okay, so if a process need to wait indefinite time, he don't know how much time he need to wait for its turn, then we say that the process is in starvation. Process don't know when he will get the, it's like a person who is sitting and he don't know when he will get the food, and if he don't know when he will get the food, then he will starve. So if a process is don't know when he will get the CPU, if somebody is telling him that, okay, after 10 peoples, that is your turn, after 10 processes 100% that is your turn, then that is not starvation. He can tolerate that thing. Okay, after feeding these 10 peoples, next turn is mine. Just like you are standing for some भंडारा यू कैन से. सो आफ्टर एक पंगत खड़ी होने के बाद दूसरी आने वाली है, तो हमें पता है वो फिनिश होंगे तो हमारी टर्न ही आने वाली है. और लेकिन अगर चीटिंग हो रही हो तो बीच में से लाइन तोड़ के अगर कोई जा रहा है और हमें पता ही नहीं है हमारी लाइन कब आने वाली है, तो हम भूखे मरने वाले हैं. तो वी आर गोइंग टू starve. Okay, so based upon that, actually, can you people tell me, I'm winding up now. This is the last important concept. Can you people tell me FCFS algorithm will generate starvation or not? Will cause starvation or not? Is there will be any process which will be waiting for indefinite time? If we are using FCFS algorithm, is that will cause starvation? Please write in the chat box. This is the final thing, I'm winding up now. Please write in the chat box. Yes or no? Yes or no? Yes, I think S is yes. No, there will be no starvation. In FCFS there is no starvation. ये ऐसा ही है, हम लाइन में खड़े हुए हैं, FCFS क्या कर रहा है, जो भी आ जा रहा है बंदा उसको लाइन में पीछे लगा दे रहा है, तो उसको कंफर्म है ना आगे वालों के बाद उसका नंबर आने वाला ही है. एक बार आगे वाले कंप्लीट हो जाए, फिक्स है वो अमाउंट, वो टाइम फिक्स है, उनको कंप्लीट होने के बाद मेरा नंबर तो आएगा. मेरे को कंफर्म पता है आफ्टर कंप्लीटिंग प्रोसेस 1 to प्रोसेस 2 प्रोसेस 3 प्रोसेस 4, if I am standing at process 5, my number will definitely come. He is talking about indefinite waiting. There is no indefinite waiting there. So there is no starvation at FCFS. Next algorithm we studied is the shortest job first, in which the process which required less time, that will be given the CPU first. So starvation may occur here or not. Starvation may occur here or not. Any process may need to wait for indefinite time. He don't know when he will get the chance for the CPU. Starvation will occur at SGF or not? Yes or no? Yes or no? Yes or no? Everyone please, yes or no? Indu say yes. Indu, you are right. Starvation will occur here, may occur here, I will say. Why? Because, okay, P1 process is there. He required 5 seconds to execute. P2 is there, that required 10 seconds. Okay. P3 is there, that required, okay, 7 seconds to execute. Now, P1 is executing, okay. P1 is executing. P3 is thinking that his turn will come next. P3 is thinking that his turn will come next because he required less time than this. But meanwhile, P1 was executing, another process come who required 6 seconds to execute. He need to wait for this also now. And when he was executing, another process come which require 4 seconds only. Again, this person need to wait. He don't know. Maybe some other process again come. He is saying that I require only 2 seconds. He still need to wait. Again, another process come that require maybe 6 seconds. Again, he need to wait. This may happens that the low priority processes, low size processes keep coming and they keep executing, and this process don't get a chance. And this happens in practical also, in real life also. And this is written in the Galvin book itself. This what I am telling to you, one example, practical example. Actually, this happened in 1970s when there was very few systems. Actually, only one system was there who was executing the processes of different scientists. All the scientists were coming with their programs and executing on one machine only. And the machine keep running for 20-30 years, keep running continuously. There was AC and all that, so that don't get means to make it cool down the system. And the machine was continuously running from last 30 years. And when they shut down the machine after 30 years, they find out that there was some processes in the system still waiting for their CPU. From 1970s they were waiting, from last 30 years they were waiting. Why that was happening? Because they don't get the chance at CPU. They were starved. Maybe that can happen actually. Maybe they were smaller processes if the system was using SJF, or maybe the system was priority based system. So higher priority processes was keep coming, and lower priority process was not getting chance actually. Okay. So there is starvation. Okay. So let me wind up. Other people are also waiting, I think, for the session. So let me wind up. And our session is complete actually. This is the last thing we are discussing. Okay. So next one is SRTF. Please keep writing in the chat box. SRTF can cause starvation or not. Can a process need to wait for infinite time in this case? So this can happen. This can happen? This scenario can happen? Yes or no? Yes or no? Please write in the chat box. Yes, Indu, this can happen again. Again, the smaller jobs keep coming, and the larger one don't get the chance. The job which is required more CPU time, burst time, that may waiting for, because the smaller processes are keep coming in the inside the system, they are getting the chance. Okay, next one we discuss is the longest job first. What about longest job first? This will cause starvation or not? Yes or no? Again, write yes or no. Yes or no, please. Right or wrong doesn't matter. Keep writing. Think over it and write. Does it say yes? Yes. Maybe smaller processes now keep waiting for long time, infinite time, because longer processes are keep coming, keep coming inside the system. LRTF. What about LRTF? Yes or no? Yes or no? LRTF. Longest remaining time first. Yes. You can think over it. Okay, you can think over it. Next one we discussed was the priority based. Priority based scheduling. There was two actually. One is non-preemptive and one was preemptive. So non-preemptive is what? Will cause a starvation or not? First about non-preemptive. Non-preemptive. There is nothing maybe. Yes or no? Yes, due to high, you are right. Is it that maybe higher priority processes again keep coming inside the system, and low priority process don't get the chance even go to the CPU. After going to the CPU, that there may be a process of preemption, but he is not getting the chance to go to the CPU, and that process is starvation. Yes, starvation can occur here and here. Okay, next was the round robin. Round robin. In round robin, starvation occur or not? Yes or no? Please write. Please write in the chat box. No, Digit, you are right. Everyone is getting time quantum, fixed time quantum, everyone is getting. Nobody is waiting for more than that actually. Okay, everybody starts standing in the queue. Ready queue is there, and even the new processes are coming. They are also standing in the queue. If you are standing in the queue, then one thing is sure: you are going to get the time. You are going to get the CPU in fixed amount of time. No starvation will occur here. Another one is HRRN, highest response ratio. Next, so there is no starvation here also. You can think over it, because he is taking care of both the processes, long processes and small processes. And there is a question I'm leaving for you. Even though I'm speaking the same thing again and again, I give you the formula also, we solve the question also from here, but you can think over it, how actually this is helping to to execute the long processes, if that is waiting for long. And the answer lie in this formula. This is the burst time. This is the burst time. So burst time is here. So if the burst time is more and more and more and more and more, this value will be smaller and smaller. Okay. So this will get less chance due to this burst time. If the process size is big, then due to this value will be smaller, and the process will not get the chance, because this is the response ratio. But due to this s is also in the numerator, because due to this, if the process will wait for long time, if the process is waiting for long time, this w is telling how much long the process is waiting, then this term will increase. Okay, this term will increase. In that case, if the process is waiting for a long time, even the longer process will get the CPU. Okay, okay, so no. And what about multi feedback queue? And one was multi-level feedback queue, multi-level feedback queue, and one was multi feedback queue. So here stay occur because there was different queues was there based upon the priority. Okay, but here the time quantum was there, so no starvation will occur. And at the last queue there was FCFS, and FCFS also don't cause the starvation. No. So that's it about the starvation, and actually that's it about this lecture also. This was the great session with you people. You stay with me almost for 4 hours. That was great. Actually, I hope I will not get the lunch at my company now. That's the great thing. Actually, I will eat, I will order from outside. I can ask them, please pay for this, and I can eat nice food now. Okay, thank you everyone. Thank you. So we meet next week again with next most important topics from programming, from algorithm, and from operating system. Next week, 3 lectures. One is from one is Monday, one Tuesday, one is Wednesday. These will be my lectures. Otherwise, the this complete series is going on. Again, the lecture will be there after 6 o'clock. I think there is a lecture, and take this lecture. Definitely, you will be able to crack the GATE exam. And please register for this GATE crash course. This is free, so register. Go in the description and register there. And if you are looking for GATE test series, we are providing one of the, believe me, the test series from Geeks for Geeks is beating all other test series. That is beating all other test series. They have very high standard. They have very high standard. I'm not taking the name of the institutions here, but we have the samples of them also. Everyone have the sample of competitors, so they have very low level as compared to this test series. So you can go through 3, and if you already have the test series of other people, you can compare. You can write in the comment, yes sir, you were right, this test series is amazing. Okay, then thank you everyone for joining for a long time. Thank you. I'm ending the session. Bye bye, take care.